What's up? Happy Friday. How's everyone doing? I'm doing pretty good. I'm just doing an earlier stream today because I'm taking off for the weekend in a little bit. Um, and I wanted to make sure to do the stream before it was time for me to leave. So yeah, we're going to do a little bit more work on execgen today. We've done some exciting things on execgen since the last stream that I'm going to show off in a little bit. And the general goal of today is that we're going to try to make a little bit of progress on making execgen, which currently is used only to monomorphize Boolean functions. So you can generate variants of a function given true or false, or combinations of true and false. And I'll get into that again in a little bit. But I wanted to extend that to be able to do more complicated things, or begin to extend it to do more complicated things, specifically around types. And it's really about SQL types, but as you'll see in a little bit, it also has to do with Go types. So whatever we end up doing here, it's possible that this could be sort of a Go specific monomorphization library as well. But we'll just have to see. I don't know how far we're going to get with that today. But that's generally the plan. So I wanted to put some music on. I'm going to try to make it quiet this time. I've been having trouble with that volume, but this time, just gonna, go for this, hit this, and turn the volume way down, just so it's a little bit of background pleasantry, So that's that. Focus. Hey, Durder, what's up? Saif, this is the last stream I will watch in the US flying back home Tuesday. Okay, cool. Well, the time zones are gonna be fun, huh? But yeah, welcome everybody. Thanks for tuning in. I know it's a bit of an odd time, but hey, what are you gonna do? Okay, cool. So here's what I wanted to do first. I wanted to show you what happened last time, just as a little bit of a refamiliarization in a sense. And to do that, I wanted to take a look at one of the tests that I wrote. So if we look at package SQL call execgen test data. So you can see in this test data directory, this is like this data-driven test format that we like to use. It's pretty neat. But I split it up into two files because as it turns out that there's really kind of two core responsibilities of this engine. I didn't realize it in the beginning, but one of the most important things that you have to do is do this templating. So generate variants given the template inputs. So those are Booleans in the current state of the world. And the other important thing that you have to do is inline. And so I made two separate test files for that just because it's a little bit easier to look at. So we'll take a look at this template test file. And the format of this thing is that up until you see these dashes, that's the input of the test. And this first line above a test is like the directive. So this is saying that I'm going to use the template directive to run a test over this file. And the idea of this test, this test actually doesn't really even have valid Go code in it, but it doesn't really matter because again, this is just sort of like a general AST engine thing because you don't really need to have valid Go to make it work. But the idea here is that we have a function B. It takes a Boolean as input, just normal Go syntax, and it returns an integer. And it has this conditional inside. And the conditional is over the Boolean. And normally in Go, of course, we'd execute one of them depending on the input of the function. But the point of this template directive up here, execgen template T, is it's saying that I'm going to generate variants of this function depending on the possible values for this input parameter. And right now it works for Booleans because Booleans are a sealed type. We know that there's only true and false, so I can generate every variant, and that's going to go away as a constraint because it doesn't really hold for the general case, obviously. But what this does is it takes a look at the call sites as well. And it's going to edit the call sites to, instead of calling these as normal Go functions, it's going to call the variants. And so we can see what that looks like down below. This is what the output of the test case is. So the first thing I'll call your attention to is that instead of just having B, there's now two variants of B, and neither of them have the template declaration anymore. They take no arguments because we've removed those template arguments. And they just do one thing: set x to 3 or set x to 4, which again isn't valid Go because I didn't put a colon equals in here, but again, it doesn't really matter. And then return x. And then up at the call sites, what we've done is we've transformed the callers. So it used to be b of true, and now it's b underscore true. And this is sort of this name mangling method that I've chosen to use to make this possible. B underscore true is what you get when you call b with a true Boolean argument. So that's all good. I guess there's another couple of things, more complicated test cases where things are calling each other, where things have multiple Boolean inputs. Like over here, we have two template variables, t and u, and the if statements are nested. So this, will correctly kind of do the right thing and only emit, this line in the case, or I guess it would be this line and this line in the case where, t is true, t is false, and u is true. And so I guess we test that down here. Everything gets mangled up, et cetera, et cetera. There's one kind of funny detail, which is that, the Go compiler will actually do a bunch of this stuff for you. Like part of the complexity here is detecting static if branches in a sense. Like you can imagine what the template engine does here is it's going to replace, and this is what it does. It lexically replaces each of these formal parameters. So t is going to become true if I call it with true. And u is going to become false if I call it with false. And the Go compiler, when it sees stuff like this, if true, something else, it will automatically get rid of those branches that are false, statically falsifiable. So I don't technically need to worry about doing that in the program. But the truth is that it generates really ugly code unless I do it, because the code will just be littered with these sort of obviously falsifiable if branches that is just kind of distracting. So I have some code that kind of gets rid of at least the basic cases where it's just, if true or if false. There's other things that it doesn't get rid of that probably we should, like if true, Boolean or false, it won't know to simplify this, or Boolean and false, it won't know to simplify this. But again, the Go compiler does it, so it's not too big of a deal. Yeah, so the last thing is that, templates can also call each other, which is kind of neat. So down here, for example, this is a template A that takes a template parameter Y, and here's a template B that takes two template parameters Y and Z. And this is just a test that if I pass in a template parameter Y to A, and I just pass it through unmodified to B, it will properly work. And that's like, what's kind of funny about this one is that it seems complicated. And in fact, when I was first thinking about how to implement it, it was tricky to think about because, well, I didn't really want to assemble a stack of function call sites, which is sort of what you'd think you need to do to make this happen. But it turns out that if you just think about it using lexical replacement, it kind of just works automatically, because what we do is we generate, the first thing that we do when we see a template function is we generate all possible variants for this template. So since it's Y, we know to generate, true and false for this. And then what the lexical replacer does is it replaces Y with true and false, like this essentially, except all the four cases. So the point of this is just that, like, you don't actually have to worry about the call sites because lexical replacement just does it for you, if that makes sense. Anyway, so that's like pretty cool, I think. And it's, it's working pretty nicely overall. I have this big branch that I haven't really pushed yet that converts like a whole bunch of these old worse templates into this sort of new, simpler language template method, which I think has been pretty good overall. Like if we take a look at, let's see, what would be a good example? Maybe this check body one. I think this is one of the ones we worked on stream. So if I take a look at this commit, ultimately what it does, I mean, it's a little bit hard to see maybe in this diff format, but if you squint, and I imagine you're probably not squinting, but that's okay. It's converting something that was this sort of hacky text template directive thing that we did with regexes and defines and stuff with comments into something that looks a little bit more palatable to people who are used to programming in Go. And it's that, this check body function, which is the post change version, has these two Boolean parameters, and then you can actually if them, like you could with any ordinary variable down in the body. And this execgen template declaration makes it so that these ifs never actually appear lexically in the final version of the code. So that's just the simple Boolean monomorphization stuff. And it's pretty great overall. I think it's pretty great. So that being said, the next thing that's kind of not great that I wanted to try to work on today or at least think about how to work on, because realistically it's trying to solve like a lot of things at once, and that's scary to me. But I want to take a look at another example with you, which is, again, this is one of my favorite operators, the distinct operator. I think it's simple and a good example for things. But I want to take a look at what we do inside of this distinct operator that's templated and sort of show you why this Boolean method doesn't work for everything, even a little bit. So what this operator does, I've explained this on stream before, I'll just give a quick summary, is that it does a ordered distinct of a column of any type. So for example, if we had, here, I'll pull my whiteboard up. This is my little intro screen, but if, for example, we had a column of integers, like 1, 1, 2, 3, 3, 5, what this operator is going to do, whoops, is that completely unreadable? We can switch to the whiteboard screen. What this is going to do is, pick out just the distinct versions, or just the distinct elements in this column. So it's going to take the first one, the first two, the first three, and this 5, because there's no, it doesn't want to take the repeats essentially. And the way it does this is just the simple algorithm that you might imagine if you wrote this thing by hand, is that it kind of, it keeps track of the last value that it saw. So it sees this one, and then it saves this thing in a little buffer. And then when it sees this next one, it checks, is this thing equal to, that was not a not equals to sign. Is this thing equal to 1, which is our last value? And if it is, then we skip it, et cetera, et cetera. So just like the obvious algorithm. Of course, the trouble though, is that, to make this happen in the general case, we have to have equality functions for every type in the system. And the whole point of this engine, to make this SQL engine fast, we want to make sure that that equality operator is known at runtime without having to do any type switches or any lookups or anything like that. And that exactly is the point of this whole templating business, is to avoid having a generic equality lookup that could work on any type. So the way that we accomplish this in this operator is using text templates. And you can see here, we use this like range directive thing, and that's telling the text template engine to range over every type that we pass in. And what that ultimately does, it's a little bit of extra, crap, and there's a bunch of other things that are similar but not related. But the ultimate thing that we really care about is this call right here, to assign not equals to. And this is the call where we take the current value v and we compare it to the last value, which is the the 1 in the little drawn example on screen. And we assign the result of that Boolean comparison to unique. And unique is, then we're back into like ordinary non-template code, because what we're doing is we're taking that Boolean and we're ORing it with some other stuff, and like then we're sort of done. Like that's the point of the operator, to get that unique value out. So here's the thing. What this assign NE thing does is it looks up into one of these template objects that we're passing in using that range directive. So I'll show you what that looks like. But it gets pretty meta. So because it's just like a deep hierarchy of these overloads and stuff like that. But we pass in this slice here, same type, comparison op2 overloads of tree.ne, which is going to be a list of all of the per type overloads for the not equals comparison operator, if that makes any sense. And what those things look like all the way under the hood, past all this slice indirection and stuff, is eventually we will get down to a thing that has an op string. And this op string is going to be a literal string that tells you how to do this comparison. I think. Or maybe it's yeah, I think it is op string. Let me see. I would like to verify that. All binary operators, I think there's probably some version for comparison operators too. Probably in here, overloads comp.go. Maybe there's a map where we map the particular operator type, like tree.ne in our case, to a string. And yeah, I think so. This is kind of this map from the AST version of each of these, mathematical comparators to the string version. Now, here's the thing, though. Of course, the problem is that this only works for scalar types in Go. And we have to overload this for things like bytes. And that's where this whole template thing is important, because if it was just scalar Go types, we could always just use not equals to, like the exclamation point equals thing, and now everything would be fine. But we don't. And if we look, there's something called bytes customizer or something like that. And I think that bytes customizer has some, yeah. So this is, I told you it was meta. It takes a while to get down to the bottom of the chain here, but ultimately somebody gets this string, string is equal to bytes.compare string. And that's going to be the not equals input to all of this. In the end, that's what gets generated. And if we in fact look at the distinct code that gets generated by this whole text template mess, what you'll see is that there's a copy of this thing for every type. Distinct int, we can look at that one. So here's the distinct op for int 16s. And if we go down, we can see this is where the comparison gets done. We run this comparison thing, and we edit the result, or look at the result by changing, editing this CMP variable, which is like, the -1, 0, 1 thing that you typically get from a comparator. Okay, cool. So, and then if we look at the distinct bytes one, just for the purposes of, hammering this point home, we will eventually see that we're running bytes.compare, and that's the magic text template business that happens. Okay, so with all of that as an input, I just want to talk about how this is the thing that we need to figure out syntax for, ultimately. That's kind of like the core of it. Like, how do we figure out a function name that can be programmatically examined by this template engine, and that is also has copies somewhere in generated code for each type? And how do we pass the current type of the operator in to this, lexical function thing in a way that allows the code generator to pick the right one? So that's kind of the challenge. And I think in C++, like, I don't know. One thing that I was kind of scratching my head over is whether you want this thing to be like a method on something, or just like a plain function. Because you could imagine just like, trying something out here if we passed in some sort of type info struct, like ti type info, something like this. And I was playing around with something called type info, but it doesn't really do anything. We could conceivably say like, okay, well, there's going to be one type info per type, and I could say something like ti dot, not equals. I could pass in v, I could pass in last val, and conceivably you could see that this would be replaced by the template engine with the correct implementation, because it knows that ti is templated or something like that. Like, essentially we would have a declaration like this: execgen template, ti, and then something would know to substitute ti with all of the possible types. And then something would also know to substitute calls to not equals on a ti to the proper implementations of not equals. But of course, like, I don't know, there's problems with this too, because there are cases in which we have cross-type comparisons. So it does become a little bit sketchy to have like a single type info be the calling object for one of these guys, in a sense. And that it's given me a bit of pause. Like, you could conceivably pass in the type info object of the second parameter in this call as well. So instead of just passing, the left and the right, you could also pass in, ti, right, RHS ti or something like that. In this case, it would just be the same ti, but in other cases, presumably you might want to be able to do a cross-type comparison, so you would be able to pass in a separate object here. But I find that to be slightly gross, I would say, because, I don't know, it just doesn't feel symmetrical. But to be honest, I'm really stuck on this question, and it's such a bad place to be stuck, because it's really hindering me from taking action. I think the ultimate, the like very first action that I do need to figure out how to do, probably, and maybe that's what I'll do on stream, is figure out how to tell the engine a list of particular templates to instantiate. Because up until now, the idea has been that, I think there's an example in this file, but maybe not. Just, taking another look at our test code. Up until now, there's like a couple of problems with this execgen template. It doesn't have types in its variables, so like I can inspect the like quote unquote runtime parameters of the function that we're templating over, but it doesn't know them explicitly. That's sort of problematic for some other reasons. But the main problem is that like there's nobody anywhere saying, you know, I want to instantiate this thing with, you know, bool true and bool false, bool true and bool false. Instead, it just does all of them. And that won't work for things that have a lot more variance, like these type info things. In fact, they might have infinite variance because they're structs with strings in them or something like that. It's not a sealed type, to use the functional programming parlance. So I was thinking that what you could sort of have a syntax like this, execgen instantiate or something, and then you could pass in concrete arguments like, you know, true, false. And then this would explicitly pull out all of it would create just the variants that were listed in the instantiate calls. But then the problem with that is that everywhere we do a template function over types, we'll have to write execgen instantiate and then all of the types. So I don't really like that either. The alternative is also that we could conceivably do some, you know, fancier analysis, like I was talking about trying to avoid, which is trying to take a look at all of the initial callers of this thing. So in this particular case, you know, we have this stack where A is called with, you know, true and false at the top, and then B is called with true and false here. So B has all the variants, I guess. But, you know, assuming that this was commented at or something, we would only need to generate the variants of B that had true. But that involves a little bit more analysis, you know. And the other a little bit sad thing about this is that I think that the Go actually has some libraries that can do this type analysis for you. You know, it sort of loads everything in, and it can give you ability to jump between these functions in a way that you can't just do with an AST. The thing is that to get that, I would have to make sure that all of the Go programs were compilable before loading them, and that doesn't always work. So these are some problems in my life, I guess is the fundamental thing here. These are the problems in my life. So I'm trying to think like what would be a good way to get started? What would be a good way? Maybe, yeah, okay. So actually one more thing while I'm just talking about the problem space here. One more important thing to note is that even given all of those problems, there's even one more worse problem, which is that in this distinct operator that's supposed to be generic for every type, we actually have to store a field of a particular Go type. So worse than just SQL types, which are represented as structs, we also have to pay attention to Go types because we have to store what that last value is. If you look at my example, the little circled, you know, one thing here, that guy, we actually have to store hey, thanks for the follow, Tom Tucka. We actually have to store last val as a Go scalar type on this struct. So there has to be some way to programmatically reference that type. And in Go, you can't do that, right? There's no way to have a type parameter, even a little bit. There's no way to have, there's no way to have like a customizable T here, essentially. So I have to come up with syntax for that as well, which is a little bit sad. Finally, I also have to come up with syntax for templating over a struct. Until now, I've only been able to template over functions, which is good enough for the original use case, but not good enough for struct. So maybe actually, I think that's going to be my first thing to do on the stream is I'm going to add templating for structs like this. I'm going to have to be able to say execgen : template. And then I'm going to pass in C++, it looks like you say type name T, and that says, you know, type name means that it's an actual C++ type, and T is the type that you're templating over. But in Go, everything's reversed, so I think I'll say T type name. And so actually, yeah, I like this. And then what it's going to do is it's going to look inside of the struct, generate n variants, name them somehow, and then also, you know, replace T here with the type that's specified. So I'm going to start with that. I'm going to make a new test file for this just so we can, you know, come up with a use case that we can actually try to mess with. So I'll call it type template. And I guess for this, the directive is going to be template. So remember this first line is like what the directive to the test engine that we're going to pass in is. Then everything else is going to be the file that we're testing. So the input to our program. So I think what I'll do is I'll just make a program that has a single struct. It'll call it foo, and it'll have a couple of members just to make sure that we don't screw up existing members, like foo int, and then also we'll call it maybe just bar t or something like that. And then we'll make sure to pass in this t type name business, and then theoretically this should, you know, be enough to instruct. Okay, right. The other thing that's missing is, of course, we have to figure out how do we tell the engine which types to generate variants for, right? This is going to say, you know, there's infinite types in a Go program because people can define their own type. So this isn't quite enough. We need to be able to say to the engine, please create variants for this set of types. So again, I was playing around with this idea of having an execgen instantiate syntax. I don't know if I love this, but I guess just in the interest of getting something going, I feel like I'll start with this and see how it goes. You know, I think the way that it works in C++, again, is that it does actual dynamic analysis. So if I had a function A and I said, like, you know, again, this is not syntax that we have in Go, but if I said, you know, A is equal to foo of int, B is equal to foo of bool, then I think that the way this would work is that it would find all of these calls, all of the static calls, and specifically create these instantiations of the struct for the types that we're caring about. You can also just pre-declare them. I'm not sure what you mean by that. Pre-declare them. So maybe you're saying like foo int struct, this kind of thing. Yeah, one kind of, you can, yeah, instead of dynamic infer, that makes sense. I think, or maybe it would be like this. One annoying constraint, and it's a super stupid constraint, is that in Go, we are not allowed to have any kind of brackets in our type names or in variable names at all. So you can't, this isn't like a thing that you can type. And just in the interest of making things like aesthetic, I need some way of telling the language to notice that a particular type is getting instantiated with the static type, and I can't figure out what the syntax would be for that. You know, for example, I could say like, over here I could say inline, like, you know, execgen instantiate int or something, but this is also super gross. Or I guess it would look like this. So I'm stuck with that as well. I think for now, yeah, you know, it is actually quite problematic because, again, I think callers will actually have to specify the mangled name unless I give them some way of avoiding to do that. So people would have to say, you know, foo int like this, and that's quite unaesthetic. But I don't know. I think I'm just gonna get started with this and see where it takes me, and then we can continue thinking about it from there. So here's gonna be my test, and my output I would like to be basically something like this: foo int struct. It'll have foo int bar int, and then foo bool bar bool. So this is just super simple stuff, but this is what I'm expecting my output to be like before we get started. Okay, so let's actually get coding. It's been 30 minutes of me blabbing about what I want to do and not me doing anything. So let's actually get started to do something. Very exciting. Let me revert my changes to distinct template because I don't actually want to change that yet. Just hit undo on this. And so we'll go over to our templater. So that's this code called template.go. And this right now is concerned again with the value template. So maybe, I mean, realistically, I could call this whole thing value template.go or something like that. But I think I'll avoid that. So the first thing that this thing does is it calls this big fat function called create template func variant. So this is the thing that searches through the AST, finding func declarations that have the execgen template annotations and making the variant. So what I want to do is make a create template struct variants function and mess with that. So I'll put it down at the bottom here. Create template struct variants. And let me slap a quick comment on this just so I don't get lost. Create template struct variants finds all structs in the input file annotated with execgen template t type name u type name dot dot dot, and produces variants. Let's see, how would I say this? I guess I also have to include that information about the instantiation stuff, which is quite unfortunate, but sort of what I have to work with right now. And produces, I guess I have to say both. Execgen template. And produces variants for every instance, for every nearby execgen instantiate annotation. I mean, it's a bit dissatisfying. The other thing that I have to think about is like, what does execgen template, you know, what other stuff does it do on a struct? And I think there's a couple of more important things that it does on the struct, which is that I think that it's eventually going to have to crawl all of the methods for the struct, if I'm not totally mistaken, because I want to be able to have the methods know ahead of time what their parent struct's type was instantiated with. Is that how that works in C++? I actually don't know. I was trying to research that last night, but I couldn't quite figure it out. Like if you if you make a struct that's, you know, specifically an int struct, for example, with a template, and there's a method on that int struct that takes as input a type parameter, does that type parameter automatically get set if the struct or class or whatever had been instantiated with the int? I don't know the answer to that, but I think that's what I would want my thing to do, because otherwise I just don't know how you would really do it. So I'll put an example. Well, we already know what the example is. It's our test case, so I'll skip the example for now. So, but whatever this thing is going to be doing, it's going to be quite simple and similar to this other function that we did. So let me just grab the beginning of it. The only difference here is that instead of searching for func decals, and by the way, this whole thing it's operating over the AST. And one thing I like to use when messing with this AST is this AST Explorer website, which is really awesome. If you haven't seen this, you should check it out. Whoops, that was not what I wanted to do. Wrong shortcut, sorry guys. What I wanted to do was actually just make a quick example of a struct here that has the annotation, so I can look at what it looks like. Type foo struct bar int, or I guess I'll do foo int bar t, and then execgen template t type name, like this. Okay, so what I just wanted to do is take a look at what the struct declaration looks like by going over here. If I click a particular thing on the left, it's going to pop me over to the right where I have the actual AST structs that are generated for the input file in Go, which is very neat. Very, very cool. So this looks like it's a type spec, and inside of the type spec, there's a struct type. So that's pretty straightforward. I'm going to be looking for dst dot, well, is that the end of it? Or it's also a gen decal, right? So a gen decal is just any old declaration. So I have to do sort of a three-way match. It's too bad Go doesn't have any better pattern matching because I have to do this all by hand, but that's fine. So I'm going to be searching for dst dot gen decals. Well, wait a minute. Or can I just always search for type specs? Can type specs ever appear anywhere that isn't top level? I don't think so. I don't think I need to search for gen decal at all. Well, I think I actually do, unfortunately, because what I need to do is I need to get this comment out, and the comment is going to be on the gen decal. Okay, so I'll search for gen decals. I'll say switch n.token. I guess I can say if n.token is not equal to token dot dst. Is it token dot? I can't remember. Token dot type. Then I can just return true. So if in this case I don't care, just gonna continue recursing through my AST. Now the next thing to search for is this, what was it again? Type spec. So let's see. A gen decal, does it have multiple specs? What does that mean? Why would it have multiple specs exactly? I feel like it probably wouldn't. I think that you can have multiple specs in the case of a const or var declaration, but not in the case of a type declaration. So I can just ignore that. So I can say switch decal is equal to n dot dex of 0 dot type. What's wrong with this? Oh, n dot specs, not dex. How could I get that wrong? So I'll switch the, I guess this is also a spec. Okay, so I'll switch on the type of a spec. If the spec is a struct type spec, because we're not going to do any template unless it's a struct type spec, we're going to quit as well. So I'll say case dst dot type spec. And you know, rather than having this get all nested, maybe I'll just do it this way. So I'll say gendecal okay is equal to n dot dst dot gendecal. If not okay, continue. That way we can stay nice and not nested, or I guess return true. Then I can say same thing for the n dot token. Same thing for the type spec. If type spec okay is equal to n dot specs, or I guess it's in this case it's gendecal dot specs of 0, not okay. Guess I actually have to declare them because scopes, return true. Okay, so at this point, I have a dst.type spec for sure. And the next thing is I need to check to see if it's a struct type on the inside. So more kind of annoying stuff. I'll say struct decal or struct type okay is equal to type spec dot type dot dst dot struct type. Does that work? I see, I just am missing syntax. If not okay, return true. Okay, and finally, at this point, we definitely have a struct type declaration. So we can go ahead and find its variants and generate them. Yeah. I think this is sort of where I would want to keep a to-do item. So to-do Jordan, make sure to save the type variant info somewhere, because we'll need to use this exact same information when generating variants of the struct's methods. Because otherwise, I think we would have to redeclare the template instantiations on all of the struct methods, which seems really nasty. I don't want that. It sort of seems like it would make sense that if I have, 5 variants of a particular struct for 5 types, I would want 5 sets of methods for that particular type as well. So we'll do that and see what happens. But anyway, we don't have to do that for now. So once I've got the struct type, then I guess what I need to do is search through the struct for things of type T. Well, I guess actually even earlier than that, I need to actually pull out the names of these things here. And I think I already have a regex for this, so I think I can just reuse that. Template RE. So I'll say, I guess I'll have to iterate through the comments on the gendecal basically. For I in range gendecal dot dex dot start. I always have a hard time remembering which is the right one to use here, but I think this is it. So these are the quote unquote decorations, which are the comments on the top of our original type declaration. So for each type declaration, I guess we don't have to have the I either. And I can just call this comment. If comment dot, well, I guess I'll say if template dot match string comment Oh wait, I need to also pull out the groups, right? How do you do that again? I just did it up here. Find string submatch, and then grab the first match. This is always weird. I don't know. Like, I feel like languages all have different conventions for how to do regex matching, and like, this is odd to me. It's like the 0th match is the whole string, or maybe that's normal actually. I don't remember how they do it in other languages, but in any case, so if I have a match, then I pull it out. It looks like foo comma bar. I strings.split it. And then I think there's one more thing, which is that in this particular case, you know, I need to process to see whether there's this type name business, or else I think it's going to be kind of ambiguous. Well, you know, maybe I don't need this type name stuff. Maybe I can just have T and U, and since we have instantiate, that'll be sort of enough because it's all textual anyway. I'm gonna go with that for now because I think it's a little simpler. So I guess I'll just do, you know, this is so identical to the other thing that it sort of seems like I should pull this out into a function. So I think I'll do that real quick. So I'll grab this whole thing. So this is, again, the thing that is going to process those comments that say execgen template. And I'll call this, whoops. I feel like the Golang like method extractor thing doesn't play well with the Vim mappings, because like it expects you to just like write a new name, but it's like sometimes it's not an insert mode or something and it gets really confused. So this function is going to be like, let's see, extract template vars from comment. And we don't need to be passing these things in because we can just return them. Okay, so it just takes in a node, and I guess I can name them here. So template vars string template deck position. What is that? What even is that? What is this? Template deck position. Do we use that? I just don't remember like what that's for. Remove the template decoration. Oh, I see. It's the ith. I see. So it's sort of like if we have 10 comments, the template deck position is the, you know, if the 5th comment was the template one, it's going to be 5 essentially. So it's just so we can edit the declarations and remove it. So that makes sense. I'll just grab this function then and use it down below. Oh, I see. And it's actually nice because we don't even need to pass in this stuff. It'll do the loop for us. So that's nice. I should have just used this function in the beginning, although it wasn't a function, so how could I have known? And so is n the right thing to pass in here? N is the gen decal, n is the original node, so this is correct. So I've got my template vars, I've got my template declaration position, and then I guess the next thing is that I need to delete it.
The computer's hooked into over 1,000 data banks throughout the world.
Hey, Ave Kenza, thank you so much for the follow. So I guess here I would have to say gendecal.start is equal to gendecal.dex.start. Yeah. Okay. Okay, so after all that, what we now have is a list of variables that are type templates. So that's great. That was the dream. So template vars is now a list of strings that have been, how do I say this? A list of strings that represent list of the template variable strings. Next, we want to generate a variant for every set of arguments, of instantiation arguments or something, instantiation arguments. And of course, the next thing is, I guess, yeah, this is where we have to extract the things that people were instantiating us with from these instantiate comments, which again, I think is probably the like nastiest thing about this entire idea. So to go back to our example, this is what it's going to look like. Execgen template t type name, execgen instantiate int, execgen instantiate bool, and the idea is that it will pick out these two things in template one for each. By the way, if you're just joining, thank you for hanging out. We're trying to write like a type templating engine for Golang in the pursuit of making a easier to write execution engine for CockroachDB, a SQL database. It's going, I don't know, it's going okay. I'm trying not to be dizzified by the amount of complexity that I know is laying in wait for me and just focus on little problems. So hopefully that will pay off, but we'll see about that. So the current thing that we're trying to do is just get a basic struct templater going. That's all it is. It shouldn't be too complicated. So I think the next thing is that we want to actually extend our function here. Instead of just extracting template vars from comment, we also want a function called like extract instantiations from comment or something, and it's going to be quite similar. So I'll make another function for that. So extract instantiations from comment. And this is going to return, let's see, so extract instantiations from comment. Wow, that's hard to spell. What a horribly named function. I'll just copy and paste it. Searches a node's comments for execgen instantiate directives, returning the list of lists of instantiation arguments for the function. I guess that sort of makes sense. For example, execgen instantiate bool int a function with this would get the result. I mean, I don't know if I need to spell this out, but might as well, right? Int like this. And those are gonna be strings, but that's pretty obvious. You can get that. Kadobes, what's up? How you doing? Happy Friday. Cool. So we're going to extract our type parameters, which is awesome, fun, great. The next thing to do would be to actually use them, right? So what we're going to do is, after extracting the template variables, we're going to extract, we'll say, let's see, instantiation args is equal to extract instantiations from comment, and I guess in this case, if this is nil, we can also just bounce out of here because honestly, who cares? This deck position thing, I don't know if we really need. I mean, I think we kind of do need it. We do want to sort of remove all of the. How come this doesn't just remove it in the, like, you know, during iteration though? That's kind of my question, right? Like, I feel like it could. Right? What is start? Start. Is there sort of an issue where I can't write back to this thing? What does this return? This returns to me a pointer. No, I can do it. So I can actually just edit this in the middle, which would be a little bit more aesthetic, I think. So I'll do that first for the original one, extract template bars for comment. This thing will go ahead and edit the decorations during iteration. So I'll just copy and paste what we did before to edit the slice. Again, I hate editing slices in Go. It's such a pain. I don't know why they don't just have a little method for it. But it just looks like this. We're doing an append with a slice before and a slice after the thing that we're editing. Where would that be? This file is like getting way too big, I feel like. Extract template bars from comment. So we grab our template deck position and we're going to actually edit it just like this. And we no longer even have to return template deck position or anything because that API just doesn't make any sense. And yeah, wait, we still need to have this though, obviously. So var template deck position int. Okay, so that's all set up. We edit the call sites of this to get rid of the extra return value. We also can get rid of the duplicate decoration editing, which was pointless. So that's a nice little mini refactor. Okay, so for the more complicated one though, with this, I think what we want to do, we kind of need to edit it during iteration, which is like always sort of a blast. Why does this have an all method? Like, what's the point of that? I don't really get the point of that, because it's already just a slice of string. I don't know what the point of that is. So instead of doing this, I think what we'll do is we'll make a new slice for these declarations, and we'll just append to it if we haven't processed something, to make our lives a little bit easier. So we'll say new dex is equal to decorations. And we're going to be searching for, instead of template re, we want to have an instantiate re. Instantiate re. This is going to match execgen instantiate. So that's that. So we'll search for all of these comments that look like that. We'll find our match. And if we do find a match, I guess rather if we don't find a match, we'll say new dex equals append deck, or new dex comma deck. Okay, so that's a little bit easier than editing the slice with weird slice tricks. Okay, now what is going on here? Okay, so our return is going to really be called something called like man, maybe I should pick a better word, but I'm not gonna. Instantiations. Maybe I'll just get used to writing that because it's a bit of a bear to spell. And in this case, I guess the point is that I'm gonna have var template args string. I don't even need this. I can just declare it right here. So I'll split on the comma. I'll grab each of the things trimming the space. I don't need template deck position like we said last time. And I can just return instantiations. And I guess, right, the last thing is just that before we continue, we have to say instantiations equals append instantiations, comma, template vars, which I really should call template args at this point, template args. Okay, cool. I think that's basically what we wanted. So wait, what's wrong? I have a pointless I, so get rid of that. All right, so at this point, we have a list of the instantiation arguments. So this is sort of the next thing. Next, we want to generate a variant for every set of instantiation arguments. So I think for this, probably what I'll do is I'll make a new function just to do this part, because this guy's getting a little bit long. Nah. Or I'll just do it. I'll just do it anyway, maybe. This should be true. These return values are kind of weird. It's like the true false is just about whether the, this is a little visitor and it walks over the whole AST, and it's true if you should recurse further inside of it, and false if you shouldn't. So that's what that's about. But yeah, I think I'll just do it in here. So basically we're gonna do, so for I in range, instantiation args. I don't need the I even. I'll just have the args part. Hey, MD Layer, what's up? Thanks for the raid. How is everybody doing today? This is some serious emote spam. Welcome everybody from Matt's stream. If you haven't been to my stream before, I generally work on database stuff. So I work for a company called Cockroach Labs
into over 1,000 data banks
DB.
throughout the world.
Thanks for the follows, Colonel Warden and Jay Zielinski. On the stream, so I work on Cockroach DB as my day job, but I'm a manager. And so on Fridays, I like to do some programming because I still like doing that even though I'm a manager. And so what I'm working on right now is a program called execgen. And execgen is a program that it's kind of like a template engine for Go. And so I was showing them this example that I'm sort of hacking on right now. Let me show you another example too. I'm going to show you two examples and then I'll get back to what I was doing. One is the value templating thing that I had hooked up already. And one is the type templating thing that I want to work on today. So what a value template looks like in execgen is I should say specifically it's a Boolean value template because it just works for Booleans right now. That will probably change, but you can have a function b like this, and you can annotate it with this execgen template thing, which is sort of similar to what the Go annotate Go like Go no inline or something. So I tried to model it off of that. You can pass in a parameter here, and that's going to find all the parameters in the function arguments that match the name of the template arguments that you specified here. And it's going to treat those as compile time constants. And everywhere that we call a function that has this execgen template annotation with a static argument like this, it's going to replace it with a version of the function that has statically replaced the formal parameter, in this case t, that was templated with the static thing that you passed in. So in this particular case, it's going to replace t with either true in the case of this first call or false in the case of this second call. And just because it's handy, it also gets rid of statically falsifiable branches so that you have some nice clean code. And the result is over here. B of true is replaced with b underscore true with no arguments, runtime arguments, but you can have those as well. And the implementations of b there's sort of two of them. There's one for false and one for true. So I don't know if that makes any sense, but that's kind of the idea with the value templating. And with the type templating, the idea is that, it's sort of more of like your traditional C++ type templating thing. A lot of details still to work out here. But all of this, by the way, is in the pursuit of making the execution engine for CockroachDB, which is a SQL system, to be a bit faster, because it won't have to do any runtime type switches, right? That's the entire point. We want to replace things that are dynamic with things that are static. That's how to make programs fast if they work on many types. Okay, so that was my intro. And again, thanks for following and thanks for joining the raid. I hope you have fun watching me struggle to make a C++ like template engine. And please ask questions. I like to talk to the chat. And thanks again, Matt, for the raid. Okay, cool. So what we were at right before you guys joined was we were looping through. This is like another hack that I might try to make better at some point. Like at the moment, we're going to have to explicitly instantiate templated structs with this execgen instantiate directive, but eventually maybe we can have something that infers it from the call sites. I don't know. But what we were just doing is the code that it loops over the instantiation comments and figures out the arguments for them and produces the variants. Okay, so right, with all of that, here is args is now the set of template variables. And I guess these are really template type names. That's a clearer way of saying it. So for each of these argument sets, what we're going to do is clone the type declaration and re-emit it, basically. So I think what we want to do there is just take a clone of this gen_decl guy. Well, I think we actually want to take a clone of this struct type because we can just reassemble this part. This doesn't have anything that we don't need. This is all the AST of Go. I don't know if you're familiar with looking at it. If you're not and you care, there's this great website called astexplorer.net that lets you take some Go source code and see like what the AST nodes, the Go AST nodes that are generated are. So I'm using this quite heavily because it's handy to know what these AST nodes are called. Okay, so first step, we're going to say dst.clone of the struct type. Struct type, like so. And we have to recast this back to a dst.struct type because Go is lacking in generics. Haha, isn't that funny? So we'll call this, new type decl. And then what we want to do is iterate through the members of this struct and replace lexically things that match each of the instantiation arguments, or rather, I guess it's each of the template variables. So these are like the formal parameters here, and these are the arguments down here. And replace them with the particular instances that we're passing in via the instantiation. So we'll say for I in range new type decl dot fields what does this look like? So fields is a field list. Well, I guess it's fields dot list. I guess we can call this for underscore comma field. We'll say field dot names. Now, why would names be? Oh, I guess it's because I guess in Go you can have something called like foo comma bar int, and they're both int. Oh, right. Well, we're not even looking for names in the first place. We're actually looking for types. That's the thing, right? So we want to say, we want to match when the type is an ident, because we don't want to do anything for embedded types, I guess. I think that's why this could be a non-ident. So we'll say if ident comma OK is equal to, well, I'll just say ident comma OK is equal to field dot dst.ident. And then I'll say if not OK, continue. So we'll skip fields that aren't declared as ordinary types, such as inline types, I guess you could say. Hey, thanks for the follow, CoolBrian95. Okay, so once I know that I have an ident, I can match it against my template variables. You know, I should probably make a map for this. That'll just be a little bit simpler, I think. So I'll say, this is what it's like a list of strings. So this is my list of formal parameters. I'll just make a quick map. So I'll say for I in range template, or, you know, maybe this thing should just return a map, honestly. Would that be a little bit simpler? We use this in one other spot. Yeah, you know, I think I'll just have this thing return a map. I think that's just easier anyway. So I'll have it return a map of string to empty struct. Or do I need the position of it? Hold on. I guess I don't need the, I kind of think I sort of do need the positions. Maybe I don't in that particular case, but I do. So I'm gonna actually forget that, and I'll just have the outside callers make a map if they need one. So I'll say for I in range template bars, I'll say var template var map, well, is equal to make map string struct, whoops. What's going on? Oh, right, I don't need that second curly brace pair. Okay, so we'll make this map. We'll say underscore comma var. We'll say template var map is equal to template var map, var name rather, is equal to empty struct. Okay, so that's that. That was slightly irritating. So down here we'll basically, if ident dot name is, I guess I'll say if underscore OK is equal to template var map of ident dot name. Okay. So we've found a spot to replace it with the corresponding template variable. I guess it's template argument. So we'll say field dot, what's wrong with this? Oh, field dot type rather. Okay, so we'll say that the ident.name is equal to, so this is where we actually replace it with the corresponding instantiation arg. So that would be args of I. Now here's the thing, we don't have I because we got rid of it. So I guess we want template var map to be a map back to the integer, which is the ordinal position within the template variable list. So this would be I here. Okay. All right. So we'll say if I okay is equal to this, okay, ident.name equals args. Okay, so great. This is the lexical replacement that we wanted. And then I think we have to do next is come up with a mangled name for the templated struct and output it. which isn't really so complicated. So we'll say produce mangled name for the struct. I think we have a bit of a function name mangler already, so I wonder if I should just copy that same method. Get template variant name, it was called. And this takes, at the moment this takes a func info, but it just uses the name permit. So I think I could just replace this with a string and it could be used in both cases. So object string. I have to edit the call sites. So this is going to be info.decal, whoops, info.decal.name.name .name. Okay. Is CockroachDB similar to what AWS is doing with Aurora? Sort of. It's Aurora is a bit different because it's backed by a particular ordinary database like Postgres or MySQL. It's kind of like a higher reliability and better in general non-single leader version of what RDS is, I think. I'm not, I probably should know a little bit more about this, but I don't, to be honest. But the difference between CockroachDB and Aurora fundamentally is that, well, there's several, but one of them is that you can do multi-region deployments with CockroachDB, and you can't really do that with Aurora. Aurora deployments, I believe, right? Aren't they single region? You can have multiple availability zones, but just a single region. There's some other differences. CockroachDB has default serializable transactions and only serializable transactions, and Aurora just defaults to whatever the isolation default of the backing databases or whatever. But yeah, it's similar to Spanner, exactly. But yeah, it's pretty cool. Check it out. We have a little, here, watch this. Watch this. You got your little, there's a link. Anyway, I'm sure you've been to the website already. Okay, cool. So we get our template variable name. And we just need to replace this one more spot. Info.decal.name.name. Okay. So we can call this again. Down here. When we want to produce this mangled struct name, we'll say get template variant name, and we're going to pass in this case, the name of the struct, which I guess is going to be struct type. No, I guess that's going to be actually the genDecal's name, I think. genDecal dot. No, genDecal doesn't have a name either. See, this is where AST Explorer comes in handy. If you go over here, what I want to search for is this foo. And where does this foo live? It's the name of the type spec. So I can say get template variant name type spec dot name. It's a single executable and running Cockroach demo. Yeah, you can run Cockroach demo and it's a full everything database. It's pretty, you can deploy it yourself in a little bit of an easier way than a lot of these other databases, but databanks. But thanks for the follow, Duck Engineering. Now that is a name that I like a lot. Duck Engineering. Okay, so we pass in object name. Now our arguments in this case is going to be, it's going to be args, and we need to do it inside of this loop. So what's wrong with this exactly? Args in this case is a dst.expr. Ooh, no, args is actually a set of strings, and we need to convert it into a set of dst.exprs. So we can say type exprs is equal to make list of dst.expr, comma, len, args. And then we'll just say for I in range args. Or should we make instantiation args? Should we make this thing return dst.idents? That's another option. Nah, we'll just do this. This is fine. So we'll say type exprs of I is equal to reach our API and go AST. This is painful. Yeah, I completely agree. It's pretty frustrating. I mean, there's another thing that I'm nervous about, which is that eventually I'm afraid that the complexity of this thing that I'm writing is going to increase past the level of complexity that working with ASTs alone supports, in a sense. Like, you can also, I don't know if you've seen the new like packages.load API. This is like Go modules has this or something. It's like some version of Go gives you packages.load. And this thing is actually super cool. It gives you so much information. You load a package, and when it gives you back is not just like, you know, some strings about the files and stuff, but it actually also gives you back this thing here, types.package, and the syntax tree. Like, it gives you more information than I have right now, like type information, right? And I think that could be really handy to have. It's got scopes, you know, it's like really got a lot of complicated stuff in here. But the thing is that in order to get this stuff to be possible to use, I would have to make it so that my template inputs always compile. So that's going to put a lot of burden on the template authors to make code that, like, you know, compiles even before template replacement, which currently isn't really possible. So there's a bit of a chicken and an egg problem. Either way, though, you're still going to be operating over, you know, regular structs. There's no pattern matching. That's kind of like the issue that you're getting after, I think. I miss having pattern matching in a Lisp language or in a SML language, and we don't have that here. That would make life much, much, much easier. But we don't have it. That's okay. So type exprs of I is equal to dst.newIdent of args of I. All right. So we pass in type exprs. We've got our mangled name, and now we just need to produce a struct copy. No, we already did that. We have the struct copy, and that is in new type decal here. So I think what we need to do is now emit. So we say, I guess, cursor dot insert before, and we'll put a gen decal, or it's going to be dst.gendecal. We're going to fill in token and specs and dex, I guess. So yeah, wait, hold on a minute. Earlier, like, we've edited the comments on this gen decal, I think, right? And so, yeah, I guess it's actually going to be valid to just copy in the gen decal's dex, so to speak. So these are the comments. We want to preserve the comments that weren't the directives. So we can say gen decal dot dex, right? Okay, so the token's going to be token.type. The specs, there's going to be a single spec, and it's going to be a type spec. Wait, what is this? This is a dst.spec. I agree that this is super painful, though. I don't know. I mean, conceivably, I could have written like an AST manipulator DSL before I started on this project, but that also seems completely crazy. So I'm glad I didn't do that. So type spec. So this is going to have a name and a type. The name is going to be the result of get template variable variant name, new name. And the type is going to be the new type decal. Holy crap, we're doing it. This might be good enough. Might. And I think the last thing is that we probably want to delete what we currently have at our cursor, so the old non-templated declaration. Okay, so create template struct variants is now a thing. It doesn't need to return anything, at least yet. And then we just need to invoke it, right? So create variants. So this is expand templates. This is the top level thing. And I think the first thing that I'll want to do is expand the struct. So I'll say create template struct variants of F. And I think that if I run this, it will probably work, maybe. Let's find out. We're going to run make test package equals, or else we'll say go test package SQL call execgen. And what this will do is run that code that I just wrote against the test data that I was looking at earlier. Okay, great. So we get some panics. That's expected. It's always expected to get some panics the first time that you run the tests. And we're getting this why? Because line 325, extract template bars from comment. So I just have something broken, I guess. Let's find out why. Oh yeah. Wait, actually, why would this be broken, huh? Dex.start.all. Does this do something different than just returning dex.start? It doesn't, right? Oh, could it be that 1 0 1 0? I think the problem here is that if I didn't find any template dex, I just have to return nil. So if template deck position, is that enough? That's not enough. I need it like a found anything. I guess I can just break early if I have no decorations, basically. If len dex is equal to 0, return nil. I think that'll do it. Try again. Okay, what happened here? Len dex.start is what I meant to say. Okay, nice. So it did something, and it did in fact produce stuff that I wanted. Check it out. Oh, but it didn't replace the types. Okay, so this is some progress, but not as much progress as we were hoping to see. So here is the, wait, let's actually run with rewrite so we can see what it produces in the file. So if I look at this file, what I got is my input was this. I have a struct that's got a generic T. I have this template. Oh, you know what the issue is that I kept in this T type name thing, which is like not syntax that I need yet. Maybe I don't even need it at all. I'm not sure. Let's run again without that to see if it fixes things. Okay, nice. So what we have is a thing that produces struct variants with different Go types, which is what we wanted. And it mangles the names as we were expecting. The main thing that's messed up right now is that we kept these instantiate comments on top, which is sort of unfortunate. I don't really like that. So I think I'll just try to get rid of that. I think I just forgot to get rid of it altogether. I was writing this extract instantiations from comment thing. And what I didn't do is, actually I was sort of expecting this to work. Oh no, I wasn't. Okay, I forgot to reset the results of, yeah, I removed the comments and I didn't reset them onto the AST node. That was the thing that was missing. So if I think if I just say dex.start is equal to new dex, then I think that will go away and our test will be doing what we expected, which is quite exciting, I have to say. All right, check it out, you guys. This is pretty great. This is pretty pog. I think this is quite a good start. And I think, let's see, what would my next test be? My next test should be if I have something that wanted to make struct variants that were over multiple types at once, I would guess I just want to make sure that that is working properly. So if I have execgen template t comma u, and I have int bool int, and I have bar t bar u, and maybe like, or baz u, maybe let's just stick some stuff in here just for good measure. Make sure that things are still kind of working properly. Let's try that test. So testing multiple template arguments. How about that? Check out what happened. Int bool int. Okay, this is working as expected as well. So this is cool. I'm feeling good about it. What would be next? Next up, I think it has to do with probably, okay, maybe what we should do is jump back to our motivating example and see what would be the next thing to edit. So the main reason that that part all mattered, you guys, is that if I look at this distinct implementation, which is one of the operators that I care about improving with this templating thing, you can see that in the struct over here, we have this thing, last val go type. And this go type thing, this is actually well, it's a generic variable that we've represented with some like kind of BS regexy stuff. And so what I'd really like is to have this look like this, last val t. And then over here, I'd really like to have something that says execgen template t, and then a bunch of instantiation things. This is gross. I need to figure out a way to get around this. Instantiate, you know, I would have one for int 16, you know, one for int 32, one for int 64. This is, you know, definitely awful. Because there's even more, right? There's like a whole bunch of types. And of course, if we wanted to add a type, we wouldn't want to have to go through every operator and edit the instantiations. I don't know how to get around that for now though. So I'm not going to try. That's not going to be the thing that I'm chipping away at. I think the thing that I want to chip away at next would probably be figuring out how to get a method that's specifically addressed to this type. So the motivating example from earlier was that there's this assign any thing. What this does under the hood is it's going to replace, if we're operating over integers, we're going to say, you know, unique is equal to v is not equal to last val, more or less. I mean, it's a little bit different, but not important. Or if it was a bytes, it would say, you know, not bytes dot equal v comma last val. And so I guess what I want to figure out how to do next is to have a function. I guess this is a specialization thing, right? This is saying that I want to have most of them act like this. I guess it's a type templated function that mostly works like this, but sometimes works like this depending on the argument. So I need to think about how to do that. I'm going to take a brief break, but I will be back within like, I don't know, a minute or something. So hold on a second. Hold tight. Okay, I have returned. You need to up your OBS game. I think it's fun to play with the OBS things. I almost think that it's like more fun to do that than the stream itself sometimes. I'm like, man, I just want like cool effects and stuff. But anyway, have you seen this guy? Oh my God, there's this guy on Twitch who does the craziest stuff with live video editing called Sushi Dragon. It's a little bit silly. I mean, it's for sure 100% silly, but it's absolutely buck wild what this guy manages to do. He has these like little keyboard finger things that he has attached wirelessly to his hands at all times, and he has all these different crazy transitions. He does like music videos and stuff, and it's all produced 100% live just like by his fingers. It's like insane, dude. It's like really insane. It's almost like not really related to Twitch. It's like a live art form that happens to be on Twitch, but it's really quite fantastic and cool. Anyway, okay. So this is another spot where I sort of got bogged down in my thinking last time. Essentially, the question is, if I wanted to have a not equals function somewhere, should that be a standalone function called like execgen.not equals or something that takes in all these arguments, like unique is equal to not equals, I put in last val, I put in this, then I put in like the types, right? So that maybe the type parameters of both sides or something. Should it be this, or should it be something that's like, instead of having a, you know, go type argument t, I instead had like a type, a concrete sort of pseudo runtime struct called like ti type info, and then I could have a method on ti, like ti.not equals, you know, v last val or something like this. I'm sort of stuck about which of these would be better. because this gives us a little bit more flexibility because we can actually define methods on this and have n versions of it, you know, for each type. It's sort of like, are we templating first from type or first from operator is almost what it feels like. I don't know. I think since on this stream, I'm looking just at the Go type template style. So this would be sort of, let's see, what would this look like in my new syntax? It would be, I guess I would have to have a T slice as well. So this would be T, this would be T slice. And then I would also have, again, this is gross. You need to figure out how to deal with this, but it would be like, you know, essentially like this for all of the types in the system, which is not cool whatsoever. You know, apd.decimal slice. Or I guess the interesting case is slice of bytes, and this turns into a call data.bytes. And then this would return a T. So if I had this set up, right? The question is basically, well, and I think actually things become sort of clear, right? Because this tells me a few things. First of all, it's going to actually tell me that it's not enough. First of all, this method needs to have a type parameter so it can know what to call the thing with. So that's something to add. It also needs to have a type slice parameter. And this is, okay, so this is telling me that the next thing I should really try to do is add this method templating that I was sort of talking about before. So let's go back to our test example. And so instead of just having a foo struct that has a type templated field, what I want to have is a type templated method, I guess, on this struct. So I'll say func foo templated or something. And let's see, this is gonna have, the question is, should this have template arguments via execgen template, yes or no? I feel like the answer is yes. That seems more normal. That's what C++ does as well. So this is gonna take a T. Now what is this? What the heck is this though? Do I have to say like T, and then do I have to have a special identifier here? Like maybe I could just call this interface or something for now. Because this thing doesn't have it. This is like not an actual type, obviously. This is like a fake pseudo bullshit thing. That we're just, I mean, in C++, again, it would be so much nicer because we can have this. And then not have anything in the runtime parameter list, but hey. Hey, thanks so much for the follow, FuncDev. Appreciate that. We're doing some function development right now, so I feel like your name is very apropos. But in any case, I think this is what we're gonna go with, just because it's uniform with the other way that we had, you know, in our, I guess we can have both of these open at the same time. So template and type template test files. In our template test file, this is what it looks like. We have a template, and it takes T, and then there's this runtime parameter that's not really a runtime parameter. So I think similarly here, we should make this a runtime parameter that's not really a runtime parameter. Okay, so I guess the thing that I want to, the only tricky thing here, and I don't think it's even that tricky, is that instead of having to repeat these instantiate declarations, I want the template engine to remember all of the instantiation declarations for the struct and to recreate them for each of the methods. So that's straightforward. I'm gonna do that now. And I guess what I need to do for that, you know, I'm gonna make a new file here because this is just getting out of control. So I'm gonna call it type template. Type template. And I'm gonna move over the extract instantiations from comment method. I'm going to move over this big fat method that we just added, which is called create template struct variants. Okay, so with that taken care of, I think what I want to do is have, let's see, I think I want to have create template struct variants return me a map that contains, I guess it's going to be a map from type name to instantiations, or instantiation args, basically. I feel like that's it, right? So yeah, I'll do that. So it's just going to have It's going to return a map from string to slice of strings, I guess. Maybe I should make a type for this. I don't know, but I'm not gonna. Okay, so I'll say ret is equal to make map from string to slice of string. So ret, I guess I can say it returns a map from struct name to, I guess it's struct type name to lists of instantiation arguments. Bro Hanser, what's up? The custom DNS is hype. Thanks, dude. I like it. Eventually I think I should have it pointed like a subset of my website or something, but for now I kind of like how it just points to Twitch. It's kind of dope. I need to also incorporate it into my like Twitch channel so people can remember. But anyway, largedatabank.com. I think it's pretty sick. Okay, cool. So this is going to return that map, and down here in the bowels of this new method, we're just going to set it, right? So we're going to say ret of type spec dot name is equal to instantiation args. Okay. So then down here we can just return ret, and then that's the end of it. Okay, so then back where we call this guy, we'll say struct name to instantiation args. Dude, this is the worst. Is there like a better word for instantiation args? It's like the horriblest thing. And then I'll say replace template method. Or, you know, maybe I should actually do this inside of this big function. That's sort of a little bit more natural, right? Because the whole point is that this is making a variant per struct. And then as a part of that, we also want to make a variant per method on that struct, right? There's actually also this sort of next level question. So check this out. Let's say in my example, I have foo, which has a type T inside of it, and I have a templated method. But what do I do if I have a non-templated method, right? Ideally I wouldn't have to generate a variant for this one, because there's no template argument, so there's no variants to do. But I think since I've made variants for foo, I would have to kind of make foo into, you know, what I could do is like separate out the non-templated members of this foo or something and stick them into another struct. So foo would sort of remain, and then you'd also have fooint, and fooint would embed foo or something like that. But I don't know. Is that like too complicated? I kind of think so. Like down here, the example, it would be like this. Type foo struct would still exist. Type fooint would exist, but it would only have the templated variables inside of it. And this would go up here, and this would have an embedded foo. Oh, is that way too crazy, you guys? I don't know. And then of course the methods that would have, it would only have the it only have the templated methods, and the non-templated methods would go on the parent struct. SMX, thanks so much for the follow. So I don't know. I think for now I'm going to keep it simple. I'm not going to do any of that magic, and I'm just going to assume that every method is templated, and if it's not, like maybe we can just blow up or something. But this is going to come up rather soon, because in the distinct template, for example, only next is templated. Reset and init, they're not templated. I guess what I could do is have the implementers do that stuff by hand. So if they have a struct that's templated, they need to guarantee that all methods are templated, or if they don't like that, they can make a like a parent struct and embed it themselves, basically. That seems maybe better, just because it's a little bit magic to do all this stuff. Okay, so create template struct variant. So I think inside of this, what I want to do is have two phases. So maybe I'll break this whole thing out into its own method called replace template. I mean, really, this is called template struct variants, and the whole thing should be called like create. Yeah, what do you call a struct plus its methods? Is there a word for that, you guys? Is that like a concept in Go? A struct plus its methods. We don't use the word class in Go. Maybe it's just like the whole type or something. So maybe it would be create template type variants versus create template struct variants or something like that. Yeah. Okay, well, I'll just call this replace template struct period. Okay, that seems good enough. Then this thing can go in here. This doesn't have to take this as an argument. So we can say instantiation map is equal to this. And then we do another pass over the AST searching for the methods and replacing the methods with their instantiations, basically. So let's do that. Wait, this has to return. This has to return the map of string to string. String, string, slice. String, slice, slice. Or a byte slice, slice, slice is really what it is. But anyway. Return ret. Okay, very cool. So we've got our instantiation map. Now we're going to yet again walk over this damn tree. We've done it many times and we will do it many more times. Same old basic pattern. It really would be so nice to have a DSL for this, wouldn't it? So we're going to be looking for func decals. We're going to be searching for the receiver type of the func decals. Let's actually hop over to AST Explorer to see what this is supposed to look like. So if I have a foo and it has a receiver f foo and a func name blah, what does this look like? And I also have to be careful, by the way, of pointer receivers. That is something that I just thought of. So it's got to work for both pointer receivers and non-pointer receivers because it just does not matter when doing this type replacement stuff. I don't think. I hope not, anyway. So this is looking like it is a func decal that inside of its receiver parameter, inside of its field list. How is that a field list though? Right? Like, is that crazy or what? Like, you can't have multiple. This is not like valid syntax, right? I mean, it's valid according to the AST. This is funny, guys. Did you know this? This is a quirk of the Go parser, is that you can put multiple receivers in a receiver list. That's not like actual syntax, right? Like, am I missing something super cool? This does not seem to be actual syntax. It's like fake AST syntax. Very nifty though. Okay, so func decal dot receiver is a field list. So I guess if len func decal dot receiver is equal to 0, we can return true. Dot list rather. Or I guess this is actually going to be nil. So if func decal dot receive is equal to nil, or len func decal dot receive dot list is equal to 0, then we can return true. Okay, cool. So we are guaranteed at this point. What's wrong with this? Equals 0. Guaranteed at this point to have a function with a receiver, so a method. Now I guess we need to match the type, right? So we need to say, ooh, and because of that, we need to return more than just the instantiation map. We also need to return the template vars slice, or the template var map. So I guess we'll have to return this guy as well. So let's say var template var map string int. And then we'll declare this up here. Or, you know, we can just make it a return parameter. That'll be a little bit more elegant. So we're going to return two things. We're going to have a template var map, which is a map of string to int. And then we're also going to have a instantiation list map, which is going to be this map of string to slice of string. All right, get rid of ret. Then down here at the bottom, we can say instantiation args is equal to this whole business, right? What happened? Not instantiation args, instantiation list map. Cool. And I guess we also have to make it, that's irritating. So template var map is equal to make map. I wish it would not make you do this, right? It's like annoying. Instantiation list map is equal to make string slice of string. Okay, cool. That was a lot of effort, but I think we're good now. We can just do return and it'll automatically send back the return parameters. So we've got our template var map and our instantiation map set up. And then finally, when we're looking at the receiver, we can map. So we can say if template var, wait a minute, hold on. This does not make any sense, you guys. What I need, I actually need a third thing here. I don't need the template var map. I just need the straight up names of the structs that I've replaced. So that's yet another return variable, I believe. So we need to have a replaced struct map string to struct. I guess it's going to be another return parameter, so I'll say, I guess it should be sort of the first return parameter. So replaced struct map from string to struct. Okay. This is quite the function. And so what I want to do here is add the name of the struct to that map. So I'll say struct type dot, or is it type spec dot name replaced struct map of type spec dot name is equal to struct empty. Okay. Finally, we can be done with that. So struct name map, comma. We've got our struct name. Now, finally, we can say if the funcdecl's receiver lists 0th elements type, do we also have to check? Doesn't this have to be a field, you guys? You can't have a receiver that isn't just a name, can you? That would be buck wild. I don't think that's possible. I'm just gonna ignore it. Oh, but it can be a star expr? What? Okay, this is more complicated. So the type here, it can either be a star expr or just an ident, I guess. So I have to be able to deal with both. Okay, that's fine. I'm not at all scared. So I'll say receiver type is equal to, I'll say var receiver type. Can't really do that. I have to just do both cases. So I'll do a switch. I'll say switch funcdecal.receive.list 0.type. I guess I really want to capture that too. So I'll say, just make this into a variable, receiver type. So I'll say switch receiver type dot type. If it's an ident, then if it's a part of struct name map, so if n.name, I guess I'll say if nothing okay is equal to n, or struct name map, struct name map of n.name okay, then I can replace it finally. So I can say n dot name is equal to what? The name would be, I have to do this template replacement thing again. I guess I have to do it n times, just like before. So I really want a method for that whole thing. But what's worse is that this time I have to be searching for all idents and not just the type idents, I think. So what did I do down below is for each of the instantiation args, I cloned a struct type. I searched for idents. You know, I mean, realistically, I could just make this into a walker. I don't need to do... I could just
Computers
walk
hooked
over...
into over 1,000 data banks throughout the world.
Hey, thanks Calcause for the follow. I could make this into a walker over any node. I don't need to be specifically looking at the fields. And then that would be a little bit more
Computers hooked into over
general.
1,000 data banks throughout the world.
Hey, Black Sunbird, thank you for the follow. Appreciate that. Right. Yeah, I mean, let's see. No, so yeah, so the thing that's so frustrating about this is actually that it's not every variable with a particular name that you want to replace. It's technically just the type variables. And to know what a type variable is, you need to actually be paying attention to the location within the thing that you're looking at. So it's a little bit frustrating, a little bit annoying. I guess, I mean, okay, so here's the thing though, like inside of the body of a function, the only places that you can have a type ident, I think are like when you say var something blah, you know what I mean? Like when you use that var declaration, that's when you put a type. And in all other cases, they would be like fresh var name declarations, like in the case of an inline function or an inline struct. In those cases, we don't care about. So actually, really what we just want to do is search for the var declarations. And is that kind of it? No, okay, so here's what it is. No. Here's the weird thing. The weird thing is that because of the way that we're pretending to have type arguments for things, we actually are also passing type arguments as pretend runtime arguments in a sense. Like over here in our example, what this is going to look like eventually would be execgen template t slice, I guess. And then like this call, I think this is like var call t slice basically. I mean, this doesn't matter because we don't need to explicitly write down the type, but if we wanted to, we could. And then since this is a method, we don't need to actually pass it in as a runtime parameter because we have this. But if we ever get converted into a situation in which we need to be passing it to a non-method function, then I think that we actually need to like add this as a runtime parameter. See ya, Matt. Thanks for stopping by and thanks for the raid again. You have a good weekend too. I think that we do need to pass this. Do we need to pass this as a sort of runtime parameter or not, right? Like this thing is going to eventually need to know. It's going to be customized based on those input types. Like this was the example we were messing with. So because of that, this is going to need to get called with the type arguments. This is the critical part where we switch over into needing them as variables and not just as type names, right? And this is again why I was interested in having like a type info struct, because then we would just be passing things that still, you know, for all intents and purposes are runtime variables and not type variables. But I feel like that's confusing. So, okay, I don't know. What am I saying? Why am I saying any of this? It's because when we were to, okay, yeah, this is the question, right? Like, eventually when we write this execgen not equals thing, what is this going to look like? That's kind of a critical part of the equation here. Let's just write a quick example. Like if it was right here, it would look like execgen inline, execgen template. It would take a t. It would take a value t, other value t. And then, right, the thing is like, what is the syntax going to look like for specialization, right? Because it could sort of be essentially like, ooh, maybe what it is like this. We have an execgen instantiate int 64, you know, bool or whatever. And then for all of these ones, we just return, this is also a Boolean, we return val is not equal to other val, right? But then if I wanted to specialize it for strings or whatever, I could say this maybe. I mean, this is elegant in a way, right? So it'd be val dot equals other val. You know, I could be convinced that this is a good thing. So essentially, what it is like the execgen instantiate. The execgen instantiate directives are the things that control which variant to use. I don't know. I mean, the other thing is that realistically, like in this particular case, like there's not that many of these. And so another thing that you could imagine is just writing all of them out. And in those cases, like you would need a way of turning a, you know, template-ish piece of code into a static non-template piece of code. And I don't quite know what that would look like either. I think that realistically, this is going to be the way to do it. I think that this is going to be the way to do it. And I think I kind of like it overall. I think it's kind of nifty. So the remaining piece, right, is going to be how do I instruct the code to turn, I guess let's get rid of execgen, just not equals with this particular context, which I happen to know is, you know, maybe one of these into one of these. And is it going to look like this runtime parameter or not? And if it is, then for sure what I need to do is have something like this, you know, T. And then this is, again, what is this? It's an interface. Maybe this is actually kind of cool. Is this cool? Is this cool? So what's going to happen here is that, you know, we pass in, you know, the template engine will see not equals. First, it's going to go down here. It's going to see not equals the declaration. It's going to see that it's using template T. It's going to see that it has a T something. And I think maybe the critical thing is that instead of just having interface here, I have to have a special declaration called execgen dot, you know, type name or something like that. And this is the critical piece that's going to tell the engine to start searching also not just for names of T, but also types of T and replacing those as well. And once that's all hooked up, then the template replacer will change. Well, the template replacer won't actually even have to do anything because it doesn't have to look at the types at runtime. It'll pass these things lexically into not equals, just as we do before. But so, right, the critical thing is just it's going to turn this into the correct variant by using the name mangling. I think this is going to work just fine. So how does that relate to what I was talking about earlier, though? What was I even doing when I was programming? I think what I was looking at is, right, editing the thing that creates these variants, thinking about whether I need to make a more generic version of it since we were just editing fields. Yeah. Okay, yeah, right. Does it have to look at idents or not? Does it have to look at just type idents or not? And I think the answer is no. I think it should just look at every ident. And if you have a problem in your code where you've made an execgen template that has a duplicate runtime variable, that's just like tough luck. We don't support separate namespaces for runtime variables and type variables. I think that's going to be the solution. I'll just make that compromise because it's just hard to deal with. So type declarations and runtime declarations have the same namespace. So what this means is that we want to turn this thing into a walker that looks like this: dst.apply. Wait, dstutil.apply. Let's just copy one of these because they all look the same. Return true, nil. Okay, so then we'll say switch and type. And I guess we don't even need to do a switch, right? We can just say ident, okay. We'll just do this exact thing. Return true.
Databanks.
Hey, thanks for the follow, James Harries. So if we see an ident, we check to see if we can replace it with anything. And I guess I can say if not okay. Well, no, I'll keep it like this. Yeah, I think this makes sense. And then we can get rid of this. And we're going to run it over new type decal. And new type decal will get destructively edited. And then this whole thing we can pull out into a function. That's what I wanted to do in the end. So it's really, this is going to be called replace create field variants or something. Like, what the heck would I call this? It's like create type variable variants, I guess. So instead of being a struct type, this is just a dst.node. We can rename this to be node. Okay, so this is gonna say create type variable variants, replaces. And this is even more general. It's really just an ident replacer, to be honest, but I guess it takes into as arguments these like different tricky things. So it's worth calling it something special. So replaces idents present in template var map with the string arguments at the index of their entry in the map. String arguments, string argument in args at the index of their entry in the map. Okay, I think that makes sense. More or less. We don't need to even do this anymore. Do we? I guess we do. Eek, ooh. A man is looking at a picture of the wall. A man is looking at a picture of a man on the wall and states, brothers and sisters I have none, but this man's father is my father's son. Who is the man in the picture? Are you riddling me, my dude? This is like, I don't even know. I don't know what to say. I feel like if I say this wrong, I'm gonna look stupid. So maybe someone else in the chat will answer this before I do. What are you doing? Are you like going around to different streams asking people riddles right now? I appreciate the hustle. I think it's a cool hustle. So we replace our type variables in. This is when we're doing the struct replacement stuff, and then the next one is just we have to do the same thing for our method replacements. And so realistically, all we need to do is say, once we find a receiver that is something that we had already templated, we're going to loop over all of the function variants. So for I in range, hold on, did I do something really confusing? Is this all needing to be namespaced by struct? I think it is. It's your mom. That's like the most meme-worthy answer.
Computer's hooked into over 1,000 data banks throughout the world.
Mikey Robbie, thanks for the follow. I think this is all messed up, and I need to make a kind of like a template struct info type myself. So type template struct info struct. This is so meta, you guys. So this is gonna have a map of string to int, which is going to be template var map. It's also going to have an instantiation list map, which is going to be a map from string. Wait. Yeah. Yeah. Okay, so it's just a bit confusing. I think I needed to have one of these per template struct, and I just had one, but I had already one of these per template struct. So this can just be, instead of a map from string to slice string, it can just be a slice string. So, and this can be called instantiations. And then that's gonna clean up the return of this function quite a lot, because we can just return template struct info map. And this is gonna be a map from string to template struct info. Get rid of this stuff altogether, and then we're left with a bit of a cleaner function. So template struct info map equals make map string template struct info. Get rid of this stuff. Okay, so then over here, what I say is template struct info map is equal to template struct info. Maybe this should be a mapped pointer as well. It's gonna make things a bit easier to deal with. Don't even need to have a named argument at this point. Okay, so struct info is equal to template struct info. We'll make a little new pointer dude. We're gonna put it into the map, and then we're gonna populate it down below. So we'll say struct info dot template var map is equal to this new thing. Struct info dot template var map equals blah. Struct info dot template var map. And then finally, struct info dot instantiations is equal to instantiation args. I guess I could just say struct info dot instantiation args directly, and then if struct info dot instantiation args is nil, return true. What's wrong with this, huh? Oh, instantiations. There's a slight problem here, which is that I don't think I want to be setting this thing in the map until way later. So I'll just do that at the very bottom once I'm sure that I've succeeded with everything. All right, I think that's basically I think that's basically correct at this point. Okay, so struct info, blah, 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 return template struct info map. Okay, terribly giant refactor done. Now we just need to change the callers again. So template struct info map. Right, okay, so this is back where we were at. Now what we're gonna do is, if we see an ident that has an info, so if info okay is equal to template struct info map of n.name, at this point we know, we know we're looking at a template method, at a method of a templated struct, basically, is what I would say about that. We want to generate an variance. We want to generate variance for each of the instantiations of the original struct, of the parent struct. So we'll say, and then we can just invoke that thing that we worked on before. So the thing called create type variable variance. Right? Is this another thing that I need to return? I think it is. I think what I'll probably do is I'll stick this type expers thing, which is a slice of DST idents, into that struct info thing, just so I can have it handy, because I'm going to use it again. So instantiations, template bar map, and as well as template arguments, or template parameters, I should say. Slice of dst.exper. Okay, so then when I actually make that map down below, type expers. Oh, wait a minute. No. This is confusing. Okay, so that's not right either. Honestly, what we want to have is instantiations. This should really be a returning idents and not strings. That'll just make our lives easier. So this is going to be a slice of dst.ident. Instead of slice of strings, we can save that thing and then reuse it again later. So template args of I is going to be dst.new ident of this thing. No? Oh. I can inline this var template args slice of star dst ident template args equals append template args comma dst new ident. Is that right? Why did I have an I before? Oh, because I was just editing it in place. Okay, I think this is gonna be fine though. Template args. Okay, so rigmarole done. This now is going to be a slice of dst.ident, and probably this is gonna mess up some other people as well. But now we can just get rid of this altogether. Don't need to do type expers. We can just pass in args. No. args dot. Wait. No, I thought that was gonna work. What happened here? So type expers. Oh, it's supposed to be dst.expert, not dst.ident. That's fine. Very easy to fix that. Not a problem. So this is going to be dst.exper. This thing has to return dst.exper as well. Man, these ASTs are extremely irritating to work with. Not a lie. Not a lie. Okay. I think we're finally going to be in business at this point. Maybe. This also has to be converted. Oh, Lord. Oh, it's good because we have pretty print experts. Okay. I think it's going to be fine. I think it's going to be fine. All right. What a mess. What an absolute mess. Okay. So back to what we were doing. We've found a method that has the receiver that we're trying to edit. And then we're going to create a mangled name for it. So variant name, there's some method called like get template variant name. The name of this thing, I guess, has to be just the method name, right? So that would be n dot name. No, so n is actually the class receiver type thing. So what we really want is the name of the function, which is going to be provided up here in the funcdecal. So funcdecal dot name, and then pass in the list of instantiation arguments, which we have as info.instantiations. Ooh, but we need a loop, obviously. So for blank args in info.instantiations. Okay, it's coming together. It took a little bit, but it's coming together. So for each of these things in the loop, we're going to get the variant given by args. We're going to set that variant on, well, I guess this is where we need to start cloning as well. So we need to say, new method is equal to dst.clone, and then we'll be cloning the entire funcdecal dot dst.funcdecal, like so. So we'll get the template variant name and we'll set it on the funcdecal. So new method dot name is equal to variant name. So we've mangled the name. This returns an ident though, so it's just setting name altogether. It's confusing when you're supposed to return an ident versus a string. It's like I keep tripping over myself doing that stuff. I feel like they're both valid, but you should just stick with one. So we set the name of the method, and then what we need to do is actually recurse through the method's body and edit all of its parameters. And then I feel like that we should be good at this point. So we'll say new method dot body. Oh, and we'll be passing this into the replace template vars. Replace template, what is it called? I have all these replace things now and they're confusing me. So get template variant name, create type variable variants. That's the one that I want. So we'll say create type variable variants. We'll pass in new method, and we'll pass in the info.templateVar map and the args. And then we're set. So then we just emit this new method as a funcdecal. So we'll say cursor.insert before funcdecal, right? Let's go back to our AST Explorer. Is this the top thing or is it like a gendecal? Looks like this thing is it looks like it's a funcdecal. So I can just edit the funcdecal. So I'll make a new dst.funcdecal. I'm gonna fill in the body, the type, the name, and the receiver. You know, I think I actually need to recurse through not... Oh yeah, I already am recursing through all of funcdecal, so that's good. So, oh wait, I don't actually need to do anything weird. I can just literally insert cursor dot insert before new method. And I think that's all I have to do. I think I'm done. Then I just need to delete the outer one. So with cursor dot delete. And then I think, whoops, whoa, I don't know how I did that. So then I think that's it. I think I return true here. I've done my DSU till.apply, and then I just return. I don't need to return anything from this. I just need to call it. Wait a minute, did I do something extremely confusing? Oh no, I see. I don't need to do this. I just need to say create template struct variance of f. Okay, I think that's it. Let's run our test cases. See what happens. I'm guessing that if my past experience has been any judge, this will panic immediately rather than do anything useful, but we'll see. We will see what will happen. Or it'll infinite loop. No, it'll panic. I thought it was gonna panic. Okay, so template var t not found. It's because this is what I explicitly didn't handle the case where we don't have a template variable on a method that's part of a struct that is templated. So let me just get rid of that because I don't even need to care about it for now. I think, let's actually jazz this up a little bit. So I want to take in, let's not do this. I want to take in a of t and return a t. And I'll just say return f.bar. And let's actually make sure to also declare a t to make sure that that works. So I'll say var t hello return f.bar. This really won't do anything, but like this part will. I think this is a good example. I mean, a is unused in this case, so it doesn't really matter, but just for the purposes of argument, let us see what happens when we run this. Yeah, one thing that's on my to-do list is making these panics that are done explicitly into error messages, because this is horrible. Template var t not found. Okay, so I guess what's happening here, I think I know what the problem is. Previously, I had been searching only for variables or like formal parameters whose names were t, and this is different, right? This is searching for formal parameters whose types are t, which is structurally different. But again, since I've made this questionable decision to just share the namespace between these two things, I think I can just edit my template replacer to just get rid of that altogether. Actually, you know, I'm a little confused though. Panic template var t not found. Oh, you know what I think it is? I think it's that I need to actually remove this execgen template declaration. which begs the question also, what happens if this is kind of nasty. What happens if you mix value templates and type templates in a particular template? That's quite troublesome, the way that I've set things up. And I'm concerned about it. Maybe I need a separate type of declaration, execgen type template of t. And then I can have execgen template just mean value templates or something. I don't know. It's a little bit unfortunate. Or does it even really matter? Like, here's the other perspective, is that like, maybe I could somehow figure out a way to collapse all of this stuff so that it all just behaves exactly the same, regardless of whether it's a type or a value, since all of these things are sharing a namespace after all. The difference would just be that Well, would there be any difference? I mean, the main advantage of these type templates, well, the main advantage of templating over structs is that theoretically you can save having to use these execgen instantiate things on the methods, you know, and like only do it on the structs essentially. But that's sort of orthogonal to the question of type versus value templates, to be honest. Yeah, you know, it's questionable. It's very questionable. I mean, the issue is essentially that like this pre-processing that I just did, I think it probably successfully generated a variant for foo underscore int and for foo underscore, or rather, oh, you know what I also am realizing is that I think I've screwed something up. So let me actually quickly fix that. I think I've edited templated to have int and bool, but really what I want to be doing is editing foo to have int and bool and not templated. So let me quickly fix that. So that's going to be here where I've set new method.name to the result of get template variant name, but what I want to do is set new method.receiver.list of 0.type to be dst.newIdent. No, I think it's actually just equals to get template variant name, right? And I guess I could call this get template variant ident because it does return an ident after all. Okay, so then over here, yeah, I set the type to be that. I think that's what I wanted. I think that'll fix that problem, but it'll still have the problem that the execgen template declaration remains, and so it'll get hit by the function template processor. Oh, what a mess, what a mess, what a mess. You know what I could actually do? This is gross too, but yeah, no, I take it back. I don't know what to do here. It's just fundamentally weird that like a struct carries type information with it. That's what's confusing me. Up until now, you've had all of the information that you needed to template something based on this declaration. And even still, you do have that information here, right? The difference is that up here in the struct, like, okay, so here's the question. If I had something that looked like this, execgen template t, comma, f, and then like f bool, right? That's where it really gets wild. And I think that's why in C++, what they do is they have a type name here and a bool here so that you can clearly distinguish the templates that are type parameters from the templates that are value parameters. I don't know. I think that this is slightly a mess. And because realistically, I am going to run into a situation like this sooner than later. Okay, so here, how about this for an idea? What if what we do is if you just say execgen template t on a struct, that's automatically going to get you templating for the members, no matter what. And then any execgen template declaration on the method itself will actually just be an ordinary value template. No, that's gross. That's gross too. Whatever. I'm just gonna do that for now and see what happens. I think actually, in fact, we can just run it. I think just by that small edit, this should go away as a problem for now. Okay, so we did rewrite the tests, which is promising, and the output is what we expected. Check it out, you guys. This is actually quite cool. So what we have is two structs with a templated method on both. Oop, but something got a little bit screwed up. This shouldn't be templated int, this should be foo int. So I got one little thing to fix there, is that this shouldn't be funcdecal.name to name. It should be args. It should be n dot name dot, just n dot name maybe. Holy brohancer. Yes, look at the power. Let's try it one more time to make sure that the receiver name is edited properly. Okay, so this is what we've got. Foo-int, foo-bool, they both get a templated method. They both have types. They've got T types. They've turned into ordinary Go types. I think this is sick. Yeah, beastly progress, dude. Yeah, I'm having some major struggles though, to be honest, because like, I'm just scared of this situation. Like, essentially, before I was making the member methods declare their templates too, like you would normally, like this. But that gets really confusing because then it's hard to distinguish like a template that was provided by the struct versus a template that's provided by runtime. Or not runtime, but like explicit instantiation or whatever. I don't know. It's like extremely confusing, to be honest. I'm like very lost at the scope of things. So basically I'm just gonna have people not pass this and hope that like if somebody needs to do an execgen template F, you know, then that would sort of be enough. And I don't know, dude. It doesn't really matter. I think this is going to be good. I think it's going to be slightly confusing for people not to have an execgen template right directly above a template method, but like that's just something to learn, I guess. Or yeah, I don't know. I don't know. Okay, so the next thing is that I know that this isn't going to work for pointer receivers, so let's just make a test for that. And then fix that as well. So I guess we need another case dst.star_expr n.x. So this is going to be if okay is equal to, let's see, no, we'll say ident is equal to dst dot or n.x dot dst.ident. If not okay, return true. All right, so we have this ident. We really want to just use this exact same logic. Except we can't. It's really annoying. It's really annoying. It's like almost exactly the same except for some small details. I'll just copy the code. Sad. It's like so similar. I mean, I guess I could like make a function and pass in a closure or something, but it seems a little bit overkill to do that, TBH. Right, the difference is that like in this case we have, I mean, like, I don't know. I feel like the AST creators could have done a better job here. Why have two types for this when really all processing is going to be nearly the same? I guess, is there a way to get this? No, I don't really think there is. I mean, I could write like a, you know, insert variance thing, and then it would take a closure for what to edit on the method. And then I could save this code being duplicated. Is that worth it? Maybe it's worth it. I'll try it. Why not? So this is going to be called, this is what happens. Like sometimes it gets so lost. There we go. Okay. So it's going to be called produce func decal variance. But then in addition to these arguments, it also needs to take in. So n here is not an expr, it's actually an ident. So I think what it'll take in is a name. So name string. And then the critical thing is just that here, oh, we could just pass in a bool. I mean, speaking of booleans, right? Like we could just pass in like a need star expr bool. And then we can just say, if need star expr, then new method dot receive dot, well, let's make this a little bit cleaner. This is going to be type tip. If we need a star expr, then tip is going to be star expr x tip, like this. And then we have to say var tip dst dot expr is equal to this. Okay, there we go. There we go. That's actually not so bad. So then we call this with false, and then down below we call it with true on this guy. And then n here is actually going to be n.name, and n here is going to be ident.name. All right. Glad I didn't give up. This is a lot better. Okay, let's run again. Check our tests. What do our tests look like? So we've got as input a templated struct with a templated function and a templated pointer receiver function. And that's what we see. So that's looking baller. It's looking quite baller indeed. Okay, so let's see. Type templates. What do we need to do next? Let's go back and look at our example use case to see what would be missing. Yeah, so, right, this is back to where it gets really horrible. Because the truth is that in this particular case here, we actually need to be able to pass these type parameters as, we need to be able to pass through type parameters. That's the trickiest thing. So instead of just taking last val and call tslice.
Computer's hooked into over 1,000 data banks throughout the world.
Thanks for the follow, Astraz. Appreciate that. Instead of just taking these two parameters that are of type t and tslice, right? What we also need to be able to do is take a true type parameter, which is just the thing that's blowing my mind a little bit too much. So it's gonna look like, T interface or something. Noah Pants Party. I like that. Yeah, I don't know. That pull request isn't all that related, to be honest, but it's like kind of related. If you're a Go programmer, you know that Go doesn't have generics. You know that Go doesn't have templates, doesn't have monomorphization. This is a project to instill a subset of Go with these things for this use case in CockroachDB of generating efficient SQL operators. So it's exciting, but it's blowing my mind. This explicit type parameter argument thing is really the thing that's getting me super confused at the moment. Yeah. Yeah, I don't know. I mean, this actually might kind of just work on its own just because of the way that the other templater was working. So I'm maybe what I'd ought to do is this a spike or something that I'd productionalize? This stuff, I don't know. It's like halfway in between. Like essentially the current state of the system is that we actually have already a templated, sort of a template engine that we use to generate these operators. I'll give you an example. This is like the the code that produces all of the sort operators. So for order by in SQL. And you can see it like it uses all this like text template stuff. I don't know if you've used Go, but there's this text templating language that you can use to like mess with stuff and put different text in different places depending on template time variables. And so this is runtime code, right? This is like, I mean, this code doesn't get run at runtime, but the output of it does get run at runtime. And you can see the output of this templater is this like, it's in a giant generated code file called sort.eg.go, which is like, tens of thousands of lines of like generated stuff specific per type. I guess not tens of thousands of lines, but just thousands of lines of code specific per type. So what I'm working on is something that's like, hopefully it'll basically generate the same code as that we did before. It'll just be easier for our programmers to understand and edit things, like, and not just our programmers, like me specifically. I work on this sometimes, and it's very hard to keep in your head at the same time the template and the input to the template. In a sense, it's like basically it's just very sort of like write once code almost, unless you really study it. So yes, this is something that we'd productionalize, but like this code itself isn't actually runtime code in a sense. Like these annotations are nothing to do with what happens at runtime. It's like what the generator does. I don't know if that made any sense, but. So the answer is right now I'm just playing around, but eventually, yes, we will productionalize this code generator. And by the way, it's not like a JIT or anything like that. It's not something that gets run it's not like this is generating fresh operator code during runtime of the database. It's all like pre-compilation. But yeah. Yeah, so this is what's so weird though, right? It's like, what does this mean, T interface? It means that I'm not gonna be able to use this parameter at all, which is fine, but I do need to be able to pass it to other templates. And I think that that's already sort of handled by the template engine. You know what it is? You know what I think I need to do? I think what I need to do next is change the value template engine to understand these instantiate declarations. I think that's the next step here. So here's the old value templater that I made that only works on Booleans. And as you can see, you don't need to mess with instantiation really, because Booleans is a sealed data type and you always know that there's gonna be just true or false. Everything's good, it's all happy. But I think what I wanna do is support this sort of syntax, instantiate. And it's a little bit annoying for Booleans because you have to like write these out, So I don't know. But ultimately, yeah, like, I mean, I need to be able to say down here as a new test case, I'll actually leave it in the other file because it is type templating still. I guess this is really like, this is struct templating. So I'm gonna rename this thing to be struct template. I don't know. It's all like very interrelated. It's another weird thing about this. But I'm gonna edit another one called type template and add some use cases there. So let's see, it's gonna be template, it's gonna be package main, and I'll have func a. And it's gonna have, let's see, the use case would be ATBU. Let's just do a regular one. So we'll have ATBint, and then I also want to be able to pass T as an interface. And sort of have somebody, I mean, it's not really an interface, but again, it's just sort of a marker. And then down here, I want to have a B that takes as argument just this T interface. And I don't know, what could it do? It could just, maybe it'll return its own input? No, right, this is when it comes, yeah. So this is really where the specialization stuff comes in. Really what I want to be able to say is, I want to say type execgen inline. I don't need the inlining here. Forget the inlining. I just need execgen template T execgen instantiate. This is how we're going to do specialization. Oh, I think I'm sort of starting to get it. So we'll have this T int, and then down here we'll have one for bool. And then what we can do is differentiate depending on what the type is that we're passing in. So if it's a bool, let's just make something up. We'll say, format.println statically invoked with Boolean. And then inside of A, oh wait, right, they're both actually called B, right? They're just specialization. So in the case of where we're instantiated with int, we'll say statically invoked with integer. And of course, this is actually going to be done with multiple things, not just int. We also want, for example, float, let's say. So we'll say number. Okay, obviously this doesn't really compile yet because it's, you know, we're repeating a declaration, but it doesn't matter because we're not trying to compile this code. This is just the input to our generator. So in my A, now here's what we're gonna do. We're gonna call B of T, right? And then up here, right, so then again, the question is what's the like beginning of the chain look like? How do you get the first instantiation of one of these things? That is still something that's confusing to me. So, yeah, like how does that even work, honestly? If I go back and look at struct template, here I have a template that has, you know, differences depending on this template type T, but still nowhere am I able to actually create one of these things from scratch. That's still a mystery and impossible, essentially. I need to figure out the syntax for that desperately, to be honest. But I think, what are we doing today? Hey, Falcon, we are working, if you can, I was just explaining to Noah Pants Party, if you hit the exclamation point project, there's something like vaguely related to what we're doing. But the idea is that we're trying to teach Golang to do type templates so that we can specialize our execution time code in CockroachDB, the database, based on the type, which we already do. It's just that the way that we do it uses a kind of heinous method that is not easy to program in. So we're trying to make it easier to program in it using these sort of annotations. You can see them on screen. The idea is you can pass in these template arguments, and the program that I'm writing will automatically, you know, expand this thing out into many variants. Yeah, if that makes sense. I don't know. I'm trying to think right now about, yeah, you know, I think what I want to do to start off with, instead of trying to get too crazy, trying to think about that first mover in a sense of like, how do you explicitly instantiate something based on a T at runtime? I think what I'll do is I'll just use my super secret knowledge that what the mangling looks like in the end. So I can say something like, you know, A of, let's call it with integers. And then I'll actually, yeah, so right, if I want to do it with mangling, I guess I'll know for a fact that this is going to look like int. You know, that's like a hack, right? But this is, I think, ultimately under the hood what's happening. So eventually I'll invent a syntax for this, but for now I'll just use it because I'll do it this way because I know what the mangling is going to do. So it's going to take a float 3.3, a bool true. And then hopefully at static invocation time, we'll get the proper, you know, calls of this thing, even though it's going through A, flowing through A into B, basically. That made sense. So, okay, so what is A gonna do? It's gonna say format.println A, so it'll print out its first argument, skip B, because I don't really care, and then invoke B with its type parameter. Okay, let us run the test. Let us see what happens when we actually run this test, see what it generates. It's possible that it'll just explode. It certainly did just explode. Can't currently handle non-Boolean template variables. Right, of course. So this is where I have to go and, oh yeah. The whole point was that I wanted to figure out how to teach the generator to know about instantiate when it wasn't a Boolean input. So I guess I have to go do that now. Yeah. It's a little bit annoying, honestly. This is going to be a pain. So I guess over here inside of... So this is the original code that did it. Create template func variants. This thing only works with Booleans. And you can see what happens on the inside is that instead of doing anything based on what the user put in, somewhere we're like literally just ranging over true and false. Where is that happening? Args possibilities. Generate all template args. Yeah, so inside, this is kind of like deep inside of this generator, but ultimately what's happening is that we loop over these param infos, which is kind of like the things inside of the angle brackets. So like T in this case. And for each of them, we assume it's a Boolean, and we use these variants that we know about, true and false, to generate all of the possibilities for the template. Now the difference here is that what we need to do is pass through all of those instantiate comments, I think. And then that's how we can try to figure out what's up. So I think what I'll do for this is, what will I do for this? I guess what I need to do ultimately is first extract the instantiate comments, which I already have a method for. So there's something, extract instantiations from comments of n. And maybe what I'll do is I'll just, if I don't see any instantiations, I'll just do this like Boolean only logic thing, just like for now, I guess. I don't know. So this is going to give me back args. I kind of need to, So we'll get rid of this thing that checks non-Boolean. I guess, let's see. I guess what I'll do is I'll make a special case for where there's instantiations or not. So if instantiations, oh wait, if args list is equal to nil. So in this case, no explicit instantiations fall back to the sort of Boolean template logic. This is like really hacky. I don't know. I need to figure out how to deal with this going forward. Again, it's really just about that inference. Like eventually what we really want to do is be able to run through all of the code searching for explicit static callers and use that as the input to these instantiations rather than having these sort of weird execgen instantiate comments, which is like a total hack. But I don't really want to do that right now because it's complicated. So I'm just going to skip it. So if I don't have an args list, then I do this guy. But if I do, then I want to eventually pass it into the thing that creates the variance. So generate all template args. This should also get this args thing. Now, unfortunately, this is used in a couple of places. Why would that be? Oh, it's a recursive call. Okay, that's all good then. So we'll pass in args. Args is, what was it again? Wait, how come I don't even have it? Args list, I called it. Which was a slice of expers. So then again here, I will do the very same thing, which is to say that let's see. Oh, is this where I'm doing that kind of sneaky thing? I'm reverse iterating over this thing and searching for, yeah, I mean, basically I just want to say if len list is equal to 0, let's rename this to args list. Uh-oh, did I just, I might have just like edited a random other file by accident. No, I guess I didn't. Okay, anyway, so if I have no args list and the current thing I'm looking at is a non-Boolean, then I'm gonna panic. But otherwise, right, this is where I sort of, instead of just looking at true false, what I want to use is just these variants inside of args list. So that's actually, it's elegant, you know? So passing in args list, I'm just going to pass in args list of everything but the last one, just like we're doing with the param infos. So len args list -1. And then here, I guess what I can say is args is equal to args list of len args list -1. So get the current set of args. And then essentially like, oh yeah, so really, I need to say like, let's see. I guess I need to say var. Essentially like what I'm looking for is in the case where I don't have this args list, I'm just going to do this hack with the true false business. Oh, you know what'd be better? Maybe instead of making these hacks, what I should do is have the caller of this thing be the one to pass in an args list no matter what, in a sense. I think that's going to be more elegant. So up here, if I have no args list, right, I'm going to maybe put this up here. Let's see. So we'll say, well, we'll make a Boolean for this. We'll say var no instantiations. No instantiations is equal to args list is equal to nil. Whoops, don't need that var. So down here we can say if no instantiations. And the reason I'm doing this is just that I actually want to construct an args list in this case. So if no instantiations, then I'm gonna make an args list. Args list is equal to you know, this is actually interesting. Because what I really want, so what's going on is that this generate all template args, this is doing this like little recursive thing where it generates all of the combinations of each of the, it's like all the permutations of the possibilities for each position, given that the positions are just Boolean. So it's just generating all the binary strings basically. The thing is that once I have explicit instantiations, I actually don't want to do that. I actually just want to use the explicit instantiations as such, in a sense. So I think what I actually need to do is only use this in the case where we don't have explicitly set instantiations, and then have another method that is used to take this and turn it into the outputs or whatever. You know, I almost think that I just need to undo everything that I just did, because I'm very close to having what I want. I just wasn't thinking about it in the right way. Because the truth is that this method here, generate all template args, it is exactly what I was just about to write. And what I basically want to do is this args possibilities things. I want to lift this up to the top and only call it if I don't have explicit parameters. That's basically what it comes down to. Whoops, what happened? Grab this. So if len args list is equal to 0, then I just say, you know, args list is equal to generate all template args. Now, how come I can't do this? How come I can't do this? Do I not have info yet? Why would that be? Right. What do I need from param infos? I literally just need the ident. And the only reason I need the ident is to check its type, now that I'm thinking about it. So this is really unnecessary altogether. Really, I just need the length. Isn't that funny? Isn't that funny? So I think really what I want this is a little bit annoying. It's a little bit annoying. I think really what I want is I want to pass in if we have no explicit instantiations, fall back to the Boolean. I mean, I don't even need args list until later, right? So I can just do this down below. So, right. So if I have a nil thing and it's not a Boolean, then I blow up. And then at the very bottom, after I've finished extracting these things, then I can generate an args list if I didn't have any before. And I can change this to do generate Boolean template instantiations or something. Instantiations. Right? And then I think I'm good to go. Then I think like this should just automatically work. Unless I'm missing something. I feel like I'm missing something, right? Because how come I'm not using args list? What did I used to do here? Where did I used to call it? I'm confused. I'm confused. Was it here? Ah, so args possibilities. So args possibilities, instead of being passed, where is that used? Ah, here it is. So just down here, I'm just gonna pass args list instead. Ah, done. Okay, that's not so bad. That's actually nice, dude. That's actually really nice. So this is not right anymore. Oh yes, it is. We extract the template bars. We extract the args list. We check if it's nil here. We don't deal with it. Yeah. Okay. If we have no explicit instantiations, fall back to making all combinations of booleans for boolean templates. I don't know. Let's see if our old tests still run, by the way. So if I run go test, let's just run like this without rewrite to see if everything passes. Explicitly, I mean, I'm mostly concerned about the old tests. Okay, so the type template one was wrong. Oh, but it's doing the right thing. Oh, this is actually sick. I think it is doing the right thing, actually. I think. Because, let's see. I didn't change the old test files. So the value template file, which is the one I was concerned about. But the type template file did change. And what we have is main has instantiated, it's run a float, a bool. A does this. This is like this. This didn't get templated, so that's going to be broken. Okay, definitely some weird stuff is actually happening here, to be honest. But it's actually really close. The main problem is I just didn't make this a template function, so weird stuff happened. But the actual reality is that we did manage to make all of the variants for the B function. And yeah, hold on. Let me just quickly fix it for A, and then that will hopefully make things look a little bit less sketchy. So I would just need to put this same thing down here. For A, I need to execgen template T, instantiate for int, float, and bool. Let's run again. And what do we have? We have... See, this is actually looking pretty sick, to be honest. Except T didn't get replaced. Why is that? Why is that? Why didn't T get replaced here? It got removed from the... Oh, you know what it is? Because I just didn't tell it to do that, I think. Like, we need to make sure that when we do create template func variants, we also replace the types. And not just the... Not just deleting the template params from runtime definition, basically. So I guess what we would do here is like... We can just run that same function again. Replace template types, if any, from parameter list. And so here what we're gonna do is run replace template vars. No, what is it called again? Ident. Oh man. I have too many things that are all called the same thing. Is it in here? Extracted. I think it's this. No. Where's the thing that I made? I just made this. It just like edits idents that are named a particular thing and what? I feel like I'm taking crazy pills. Where the heck is that? Where the heck is that? I mean, monomorphize template, it's not that. Replace template vars, it's not that. It's like it's searching for idents, right? It's like it's a little loop that finds the idents. Is it this? Create type variable variants. Replaces idents present in template var map with a string argument in args at the index of the entry in their map. Is that? This is a confusingly named thing because it's not really variants, right? It's like variant singular. But I think this is the function I was trying to find. Okay. Then in the thing where we're creating template func variants, after we delete the template params from the runtime definition, then we just call this thing called create type variable variant. Create type variable variant. I should really rename this to be like replace type variables. Okay, that is a better name. And what does this thing take? It takes a node, which is going to be the parameter list, so new param list. Oh, but that's a field, that's like a list. Can I pass in, what is n.type.params? Field list, is that a node? I think it is. Template var map. What is this? This is a map from the this is so confusing. I feel like I've made this a little bit complicated, a little bit too complicated. Because, for example, why isn't this just a map from string to expr? It just doesn't make any sense. Could I just make this a map from string to expr? Does anybody ever use the I here? Place type variables. I feel like the answer is like definitely not. Okay, so one quick more refactor, and then I think we'll be good to go. Which is just that this thing should be a map. Oh, I know why it's done this way, right? It's because we have multiple instantiations to do. Okay, so it is important. It is important. And what we want to do then, we need to get a map from the, and we basically have it up here, right? It's like, this thing gives us back all of the template variables, but we don't have their positions, do we? That's a little bit annoying. I guess we didn't need them up until now. How is that possible? Oh, it's because we always had Boolean, so it didn't matter. So this needs to, yeah, this needs to do better. This needs to come back with a map. Right? So this is going to be a map. Ret is equal to make map from string to int. Template vars, it's going to be a map from string to int. Extract template vars from comment returns a map from the template variables in an execgen template declaration to their position within the list. And then here what we do is we say ret of strings dot trim space v is equal to I, and we don't even need this thing anymore. And then we say return ret, and then we check who's calling this. And here we can iterate using the keys instead of the values. And likewise over here. So this is going to be... Oh wait, did I already have the information because it was giving me back a list in order? I still think a map is more convenient, so I'll keep with that. Oh, and I made one right here and replaced template structs. I feel like I'm going back and forth a little bit. That's pretty silly. So I don't. I can just say template vars. Var map is template vars, like this. Okay, that is a nice simplification actually. Okay, cool. So coming back to here then. This thing is now a map. We're iterating through it. Now down here in replace type variables, we can finally pass in that map. So template vars. And then this is going to be the list of concrete instantiations, which is now called args list of I. So this is actually going to happen down below when we clone everything then. Yeah, so it's in here. Oh man, you know, this is frustrating. I didn't need to do any of that. Hey, MD Layer, welcome back. What is going on? We have made some good progress in your absence. We're about to have the ability to pass type variables through things, which is kind of cool. Straight chillin'. I did just do a bunch of extra work for literally no reason, which is frustrating, but sometimes that does happen. So I think we can get rid of this, go down here, and then inside of monomorphize template, instead of passing in the block statement of the function body, we just pass in the entire n itself. And I think that that will actually make things a bit more straightforward. So new func is equal to this dst.clone of n, and then convert this thing back into a func decal, right? Is that what n was? N was a func decal. Monomorphize sounds so badass. Yeah, it's a good word. And then I think I just say name is going to be new name, type is going to be new func.type. The problem was I just wasn't replacing these variables in the type of the monomorphized function thing, which was troublesome. But I think with that fixed, I'm hoping with that fixed, this will actually work. Hold on, let's find out. So we rewrite our tests. Oh, I have to go soon, actually. Time has gone quickly. So let's see. So if I look at my type template, what does this look like? Does it look good? So let's look at the test case again. We have a giant mess, but it does some good stuff. We have a template A that's type templated and value templated. No, sorry. It's only type templated, but I can actually pass through the type as an object, even though this is sort of like fake syntax. This thing is important. So what does this function do is it prints out A, which is a generic thing. It could be an int, float, or bool. And then it passes just the T, not the like instance of A here, but just the T itself as a type, which again makes no sense at Go, but it doesn't matter because I'm doing whatever I want. I pass that to B, and then depending on the type that I pass to B, is it an int, is it a float? Then I'm gonna print out statically invoked with number. If it's a bool, I'm gonna print out statically invoked with boolean, right? Okay, so what did we generate? Did it work? Our main, we call A and 8 float. This stuff is a little bit, I had to hack around that because I don't have a way of explicitly calling things with types yet. I need to figure that out, but so I'm hacking around it by using the mangled names that I know are going to be produced. But down here, I am properly calling the right monomorphized version of B, no matter what, right? I'm calling it with bool, so I call B bool. I call it with float, call it B float. And then down in B float, B bool, they're all kind of done right? You have the float variant that says statically invoked with number, same as this one. And then for bool, it says statically invoked with boolean. Okay, so I think it worked. I think it worked. I think we're good. And I think this is where I'm gonna call it for the day because I actually have to run and go drive out to the beach. Would annotating call sites with template parameters make things clear at all, or would that make the pass through harder? Yeah, so I do want to do that. So you're saying like, just as an example, instead of passing B of T through as a thing that looks like a runtime parameter. I mean, this is like the most hacky shit of all time. I completely agree with you. You're saying that instead of this, I could say execgen, instantiate or something. I mean, in C++, it would be really elegant. You just say B of T of nothing like this. But we don't have that flexibility in Go because the parser can't deal with it. I challenge you to think of syntax for this because what I have is jank. Like, is it this? Is it execgen call? Is it, what is it? I have no idea. I don't know what the right thing is here at all. But I think we'll get there, I think we'll get there. Yeah, so I don't know. Anyway, but thanks for hanging out, you guys. This was fun. I think we're making some decent progress on this. I'm actually pretty pumped about it in general because, I mean, it's pretty badass, I think, just in general. And I also think that it's going to help us significantly write these templates, which is the general main important point of this whole project. Execgen call sounds cool. So just for the fun of it, I'm gonna find somebody to raid because I like doing that. So if you wouldn't mind sticking around and seeing what happens, that could be fun for all of us. I'm gonna try to find somebody who's doing some programming stuff that looks interesting. Last time I think I picked somebody who was doing some really just like not that fun stuff, which I don't know. It was a little bit odd. It was like some game development, but there was just like a bunch of dudes on a Discord like yelling at each other. So I don't really know what the deal is with that exactly. But how about we raid this dude? This dude looks like he might be interesting. Okay, so say hello to this man. I don't know what this is, but it sounds kind of cool. So we're gonna raid Madhouse Steve, somebody who I don't know who that is. But please say hello, introduce themselves, and I'll catch you guys next time. Thanks a lot. See you next Friday. I'm not gonna be streaming this weekend because I'll be at the beach, but I'll see you next Friday. Okay, bye.